Why is this thing autofocusing? My node red flows that are responsible for setting up my cameras ahead of stream are not working anymore. I need to go work on them a little bit. All right, for this one, I then need to go to the chat and pop it out, and then close the window so I don't get double audio. There we go. That would be only the Twitch people would hear the double audio because the computer audio goes to a special track that doesn't get broadcast. All right, so let's hit play on this. And a little bit of tunes way in the background. And I'm going to go to, well, if I hit BTS procedure, this button, that should reset the camera. And now it should not autofocus. And of course, my my desk lights also have broken. They don't work. This is not supposed to be purple. But before I work on that, I need to move the big pieces of test equipment out of the way. These things are heavy as hell. All right, let's get this one. And actually, I got to pick it up on two sides so that it doesn't knock the other one off of the stool where it's perched haphazardly. Yeah, these things are crazy. I think my best bet is to gut them. Completely gut them and use them for other project stuff. Like turn them into modular synthesizer things. That could work. Jeez. All right, that's that. They're about the size of modular synthesizer stuff, right? Yeah, they are. They're exactly the height. So if I figure out how to put rails on them, I could turn them into. I'd have to redo the power supplies though, because those are way too hot. Way too old and loud, rather. Although it is cool to hear when you power it up, those fans spooling up. Because they go, it's so cool. All right. Why am I out of breath from that? Why am I out of breath from that? All right, hold on. So we got to look at some debugging stuff here. These were messages coming through for the camera calibration. So we don't really need to bother with these, although the message ID and the payload is undefined coming out of this set input settings. Request, set input settings, message payload. Undefined. I don't know what that's all about. Don't know what that's all about. Oh, do we have Twitch chat up too? Is that up? I think it is. I didn't touch it from last stream. There's that chat. No, I don't have Twitch chat popped out yet. Okay, hold on. Let me find you. Let me find Twitch chat. Twitch, where have you gone? I gotta go to my Twitch channel. And I gotta mute it. It turns on muted. Good. Go to this thing. Hey, what's up, Proteus? Yeah, I missed your message because I didn't pop out chat yet. Which one? Which one pops it out? The gear, and then pop out chat. There we go. Okay, there we go. Now we should have chat up. Hopefully that'll work. Hey, watchmakering too. Missed a couple messages. How's everybody doing? Okay, so I'm looking at my flows here, and stream state changed. So we're looking for what's coming out of that node. OBS WebSocket output starting, right? So output state, OBS WebSocket output starting. Invalid message received on input, and that is which node? That's bulb 1 gets an invalid message received. But if I set something to trigger this, it will turn the bulb red. And I've tested that. I can take this toggle, and I can connect it here, deploy. Okay, the bulb is purple. You guys aren't really going to be able to see it change colors because it doesn't really, it needs to like bounce off of something for you to see it. But if I hit toggle, there we go. It injects toggle, and then that works. So why is it not setting off properly? Because if I set this, it's just fine. Do I need, like, what is coming out? So the debug here says, so this is receiving an invalid message. If I send this WebSocket contains, and it goes out from there, that's going to come into the debug. So where did it receive that? node debug 1, stream status changed, output active true, output state, OBS WebSocket output started. So basically what I would be doing is sending, like if I send this toggle, that turns supposedly orange. It's supposed to be orange, it's not. Let me see here. Hold on, I gotta keep an eye on chats over there just in case they're not working. Not a lot of people are talking, so. Like, okay, I send it, oh, message.payload, output active false, output starting. So, started true, output active false, output state, OBS WebSocket output starting. It is the same message. It is the same message. It's the same thing, only with a couple extra quotes in there to make it into proper JSON. So why is the message coming out of here not keying off of this? For all intents and purposes, OBS WebSocket output started. Does that need to be in quotes over here? No. No, but these messages work. When these messages are sent, it works. So should I put a trigger in the path? Maybe I need to put a trigger in the path in order to triggerize it. But this thing is saying that it got an invalid. We're not sending anything out on the red. No, but this bulb says it gets an invalid message. How is it getting an invalid message when we change the payload? We set the message payload over here. How does it get over here and then be invalid? That don't make no sense. I also found out that in order to cull repeat messages, you could just literally drag and drop the filter block in. This filter node right here, that keeps repeat messages from happening, and it does that by default. You just have to kind of select where you put it properly. So now, when I close OBS, it will turn off the OBS connection status, but that OBS connection status will continually try to reconnect to OBS. And as it does so, it'll send a message down the line that'll then get caught by the filter, and so my light doesn't blink constantly. It checks like once a second for a connection. So then, what the hell? When I open up OBS, this thing has just a fine... I mean, do I need to split the flows? No. See, this is message payload contains connection closed or connection opened. And that works just fine, right? But when the stream state changes, the message rolls through that stream state changed, message payload is an object, and the object is this JSON, output active false, output state, OBS WebSocket output starting. And so as such, it would trigger the orange light and go to bulb 1. And then almost immediately it gets the second message because it connects so quickly. Invalid message received on input. Message, string 33. Invalid in here. Yeah, it's Node-RED is fascinating to me too. I'm starting to kind of get the hang of it, but not in any kind of a functional sense. So you guys are witnessing my struggle live on the air. This is in fact me learning how to use software platform, which is vaguely programming. It's sort of, you got to think of it as flows. Everything is flows. And you can replace and change stuff on your flows in order to direct them to the right place. And then there's like a layer that you can peel back where all that stuff that went into the flows is still there. It's a weird way of thinking about things, but you're kind of squishing something through pipes that can influence the interactivity and the physical real world things. Although typically with Node-RED, you don't have to be doing physical stuff. So. What's that? It reminds me of, what's up, Watchmaker? It reminds me of FreeMind, which is flow stuff, but without automation of physical devices, just for laying out the ideas. It's essentially that what Node-RED is, because you don't need the physical stuff to do Node-RED, and typically people don't. It's just for us, we're using it to do smart studio stuff. So like, Why does it fail here? Whatever comes out of here hits this and gets changed. It should just change. That's what that node is. So why am I getting invalid receipts here? If I can verify here that the toggle is capable of changing. Because this should change it. I mean, that's what it does. Set message payload to be this. If I put it on change, no. It should be on set. The value as this, and I know that works because if I toggle it, it works. I could change it into a toggle, but that seems like not the way that things should be working here. And they're very specific too. Started, stopped. I could do just the true and false of whether or not stream's active, and then I got to get rid of my transitional colors. I was hoping that it would be able to hit it with like a transitional color. Maybe I need to like slow the messages down. Payload unfind. So that's the command. That's the camera command. What's this wizard orb? This is going to be my stream status indicator, so that I can ponder my orb. But this is so that I have. What's up, Ultimate Mall Ninja? By the way, long time no see. Or maybe you were here yesterday and I just didn't notice. I'm sorry. This is a Tasmotized light bulb. It's a smart light. It does RGB and white. And what I'm doing is I'm trying to make this an on-air indicator. And so it's got a complicated amount of interactions that it can do. For instance, when I start up OBS, the light turns purple. And actually, I should make it a little dimmer than it's been. So let me do like 20 on that one. Done. Because that's pretty striking when that one actually does its thing. This is just an override down here. So if I go get stream status and I send it, that's gone. Well, it's been read. I don't have I need to give it a different override. Let's override it and make it green. Green. Deploy that. Close. So you can see here, it's purple because I started stream. But then if I hit green toggle, it turns green, which would mean I've stopped stream. Green means you can leave. Use the Windows update. Yeah, I want to update Windows right now. That's a great idea. Just a great idea. So, like, if I get the stream status as true and false, I can actually make it work perfectly fine over here. I need Leb. Where's Leb TV Live? He's probably busy doing Leb TV Live stuff. See, this one I'm looking at output active, and it's true or false, and it just simply goes over to the next flow, right? It gets routed to the next flow, and that next flow is a change. And so we set the message payload to be power on, dimmer 40, color red. Done. What if I get rid of, well, I won't be able to test it, but maybe it's the fact that two messages are coming in such rapid succession. What if I toggle two at once? Well, it turned orange and green in rapid succession. You can see that it kind of like blinks green. So that's that. That doesn't do anything. Balls. I don't know why my flows are broken. Is it Tuesday already? I made a follow-up to my announcement to say that I'd be going on tomorrow because the person that was supposed to be here is very wishy-washy about leaving Philadelphia. They decided to stay in Philadelphia where they will be assaulted by an airliner, apparently. I wonder if they could have seen, no, they're not facing that direction. They have a very nice apartment, very nice condo where you can see a lot of the city. on huge, like ceiling to floor windows. And I don't think they would have been able to see that. Maybe. Which way are they facing? They're facing... No, they're facing the opposite direction. So the part of their apartment that connects to the rest of the building where there aren't giant windows would have been where you would be able to see that accident from last night. Crazy stuff. That thing came down like a cruise missile. I have this pixel matrix display that would be cool to Tasmotize if possible. Only control is through phone Bluetooth. It would be nice to use PC like your LED. Just use to show I'm in meetings on the phone. I don't get in. Oh, to show if I'm in meetings on the phone so I don't get interruptions. Interesting. That is definitely a doable thing. Screens on Tasmota are not a typical thing, but you could get like an ESP something or other and run it with that. There's a lot of options with a matrix display, and you can get boggled down pretty easily with it. I don't know what I would do with Tasmota. Like, you could do strings of LEDs on Tasmota. It might be a little bit crazy to get that totally working. If phone Bluetooth can do it, PC Bluetooth can do it too. That is true. That is true. That is true. That is true. You may not have to take it over. Bad week for planes. Yeah, really. And you just flew. That's nerve-wracking. Well, I'm glad you're safe. Glad everybody here is safe. The people who aren't here are not safe. Fuckers. What a weird sentiment. I don't understand what's going on here. So this received an invalid on input. Can I look at its log? Oh, I don't know what to do with help. Hold on. Safe, made it home, and I flew American. Jeez. Ah, man, this is. I'm guessing Leb is busy. Oh, here's an input command thing. Oh, that's nice. Oh, cool. I did not know. I kind of guessed at what the input command would have been. It's kind of funny that you can just give it a color name and it'll just change colors. I'll have to remember that's there. that is a little bit soon to be making that dark of a joke. Although, you know, the making light of things is a way to survive in this world, in the year 2025. So we've all kind of been through a lot. I understand the need to make dark jokes. I'm guilty of it. I just made a couple. Why is this not working? I mean, I can make it green. There it is, nice and green. And I can make it toggle a stream status. So there it went red, very deep red. Yeah, we really have. It's been a long year, and it's only like a month into it. January just would not fucking give up. That had 31 days. That's unprecedented. Nobody could have predicted that. So for some reason, whatever's coming out of the other end of this thing hits the change node, but then the change node should just turn the message payload into what I need it to be. So what's going on? What's hitting it? And the debug shows that what's coming out of the, where are we coming out of? Debug 1, and that's coming from where? Which one? Because debug 1 is connected on both ends. I don't want to get rid of these flows right here because this is for me starting stream, and I haven't really mastered the whole bandwidth mode setting yet. You can check your bandwidth, and that technically puts your stream up and down without broadcasting. But I mean, I could always cut and paste the stream key out, but then it would be connecting, and it wouldn't connect. So I don't know. Anyway, so this data is kind of sacred right now. So this payload undefined is from here. That's from my set FPS. So that has nothing to do with what we're doing. So then we have, so undefined, invalid message received on input. That's bulb 1 is getting output active true. So stream state changed message payload object, and that's at debug 1. We don't know which end of this that's coming from. Maybe it's not coming out of red, but it appears as though, and by the way, orange and yellow, I have access to. So there's yellow. And so giving this thing the JSON, output active true, output state, WebSocket, output stopping, triggers the contain started or stopped, and then goes into the color message just fine. Which is baffling because when it comes from this node, it's all effed up. It comes from this node, it triggers the right path, I guess, and then one of these goes active. And it changes it, and then it's invalid. Invalid message received on input. And then this is an object output. OBS WebSocket output started and wait. Started and started? Started. It's the same thing. So that would be on one end and the other. It started coming from here, and then started coming from here, going into the debug. So, okay, I have an idea. Stopping. Oops. Stopping, and we compare them. There we go. There's no difference. Message payload, output, node, debug 1, output active true, output state, OBS WebSocket output stopping, and then the same thing comes out the other end in the stopping node, and somehow it goes through and it works. But yet, when I send it this one, stream state changed, message payload object, output active, same thing, output state, OBS WebSocket, output started, somehow is invalid. I would love to know what the message is that it's receiving, because functionally I don't think there's any difference between, well, that would be something to send when, something to test when the stream goes down. So let's set that up, I guess. There's stopping and stopped. I should capture now. It's going to be a lot, but you know what? I'll be able to at least know that the message originating from here. Let me get this one too, and see what happens to it along the way. I think there is like a system of logging that'll do that. Oh, I can't connect the flows. Excuse me, I'm hiccuping. I had lunch just a minute ago. What's going on with this one? Oh, it's just hanging out. You just hanging out there? Or have I did something. The input isn't liking me anymore. Oh, there we go. Got rid of it. Okay, so there. That's going to be a lot of messages, but I'll at least be able to compare them when the stream goes down and see what's going on. So in the meantime, I'm just going to do that one, and now we have that message there. I don't know why, like specifically coming from stream status, stream state change, why it would be messing it up. Because looking at the messages, at least where it originates, you know, OBS WebSocket output stopping, and this is output active true, output state. The same exact packet is down here, and my toggle packets look exactly the same as those. There's no functional difference between them. Output active true, output state. I mean, it's just the same thing. Same stuff. And maybe it's the speed that messages are coming in. That's the only thing that I could think would affect it then. But we tried toggling two at the same time, and it seems to just kind of come in like order of received, and it was able to do two things toggle at the same time. Very strange. I've been looking into making my smart stuff not be able to phone home, but a lot of my stuff is TP-Link that isn't flashable. So segregated VLAN is the closest I get without replacing most of my stuff. Over the break, there was a Blue Sky post, and what this person had done, I forget if it's a guy or a girl. I think the PFP was a girl, but who knows? Anyway, point is, what they were doing is they took an old phone and they put all their smart home stuff on the old phone. So it doesn't phone home. It has Bluetooth. You charge it. You have a little remote for all of your home stuff on the old phone, and that keeps it in its own little segregated no phone home setup. Yeah, I'm just a little confused about how in the world I'm supposed to get this flow to not be bad. Oh yeah, I need to set up the admin for Tuesday. Actually, wait, I think Tuesday's already set up on the command. No, it's not. Hold on, I gotta set it for Tuesday. Tuesday is the 33rd of January. 34th of January. Feb. Oops. There we go. Command set. All right. Developer options. Yeah, I'm kind of stuck on this one. I don't know. When stream stops, I'll get a log of a message flowing through, and I'll see if green and yellow are coming through too quickly or something. But really, honestly, like, it should be working at this point. There's nothing. I don't see a big difference between the two messages, except for the fact that I had to put a lot of quotes into this in order to make it work. I had to put quotes inside of the JSON, but in the JSON editor, that looks fine. Output active false, OBS WebSocket output starting. What is, I mean, I don't have a object viewer for this. And here we go. Okay, so it is in quotes in this. So the object is definitely stringified. It's in the string. Stuff can still phone home, but it can't see my main local network, so it has no information. Oh yeah, no information that you care about them getting. Hardest part was making it still work with she who shall not be named, which collects enough info on its own. Yeah, that thing. You know, there's been a lot of traffic analysis on the lady from Jeff Bezos's house, and they really don't phone home without an activated command. People would have probably reported on this by now, but that's to say, like, it still gets stuff like your yeah, you can ask it to do. They thought people would be using it for that, but what it really, in reality, what it really is, the Alexa is the most advanced kitchen timer that exists, because it's a verbal kitchen timer that does unit conversions and looks up quippy little things that you're arguing with people about. That's all it's good for. And the engineers at Amazon probably realized that, but I think they were pushing it forward because they thought everybody would be using it to, like, purchase more often. But it's just a Chumby or whatever. What was that clock that you could talk to? Google Home, most used for alarms and timers. Yeah, it's like really good in the kitchen. It's really good in the kitchen because you can just ask it to put up like a timer, and you could name the timer, and you could add time to the timer and stuff. You can add and subtract time from your timer. It's great. You do all kinds of fancy stuff. And then you say, what does a fox say? And it goes, reorder battery reminders. I have not given it the authority to that. You can also request that it go into laconic mode, where it doesn't give you all this bullshit stuff. Oh, by the way, did you know that there was a sale on... No, shut up. You're in laconic mode now. You only respond to my commands tersely. Then there was the YouTube channel that I was following where the guy actually made the... he plugged it into AI. He plugged the voice lady into AI, and he made it context aware. So he's able to say, like, do my morning routine stuff, and it'll turn on and off lights and blenders and stuff like that as per his morning routines sequence of events. It was kind of cool, a little bit scary though. It was more like the Star Trek computer in that it could infer what you meant. You know, it's the same reason that boiling hot plasma doesn't pour out of the replicator when Picard asks for tea Earl Grey hot, because some other wingnut on the ship defined too hot as the temperature of the sun. You know, that kind of thing. Context awareness is part of the Star Trek computer's whole thing. And so plugging one AI into another kind of allows you to have commands that are a little bit less specific and more aware of what's going on. So if I'm in this room and I tell it to, I don't know, give me some light, it'll know to turn on the lights in that room. That kind of thing. If I say good morning, I have to go through a sequence of events. That's kind of neat. My favorite's when they use an Arduino to make the Billy Bass fish talk when the assistant talks. I'm hoping to do something like that with the Furby and the fart noise maker with Node-RED. So we can make the stuff that powers the fart box, that powers the Furby into Node-RED stuff. And then I can kind of give it that interaction. You know, there would be weird things like that if you had replicators. There would be weird people would do weird, truly weird shit. The limits of the human imagination are at times boundless, and at other times really creepy. That was, who did that? That was somebody's comedy bit. It was about beaming. Wait, was that was in Breaking Bad. That was in Breaking Bad. That was good. That was a bit from Breaking Bad. It's an eating contest. You're beaming food out of the stomach into space. USA would ask for a tub of coffee. Yeah. Captain Janeway here. I need a gallon of coffee in my ready room. In a sippy cup that's as big as my head. Ew. Those I want to put aside because they'll come back in later. And then we'll get the module tester module over here because we're going to do a little bit of the more fun bench work and poke at a couple things with solder. I got my storage containers, so I get to have the fun task of going through all this stuff that I just recently acquired. Well, this is like 9 months of parts. 9 months of parts that I have to go through and put in bins, which I was considering whether or not I wanted to subject you guys to that. I was like, listen, this transaction goes both ways. I'm not just here to entertain you guys. Maybe for once you guys can entertain me while I do some kind of a menial task, like putting stuff into bins. But I had a second thought. You guys are lucky that I did. I decided not to subject you guys to that sort of Geneva Convention violating torture. The heady kind of torture. The kind that really kind of brainworms. Oh, I can't say brainworms anymore because it's associated with politics now. What a fucking world we live in. How about that, huh? I always talk about brainworms. Now it's political. They made brainworms political. IV coffee drip. What I need that Star Trek medical shit. Yeah, because of RFK and his brainworms. Don't you know? Aren't you up with current events? Fuck's sake. All right, that's one piece of the puzzle. Let me get Dave's. This one is Dave's because it has the gaffer's tape over the name. Dave's M303 is the guinea pig. The other viewer's 303 is to be repaired and then returned to them. Although, you know, it's a tough deal when somebody sends you something like this and there's like no strings attached. They're like, repair it or keep it, I don't care. right? You could send it back or not. I don't really mind, just as long as, you try. And like, but I'm not gonna fix it and keep it. Like, I'm gonna send it back. Of course I am, I thought it was a turd bird. Yeah, I guess he's that too. The Venn diagram isn't just two circles. What else do I need? Oh, I need cables. Where did those go? Well, these are all nicely coiled, so I don't know if I want to use those. There's two that are probably in a bird's nest somewhere. I think that's these. Yeah, that's these. Okay, my input and output monitor. The frequency generator we don't need because we have one. And so I can use the modular synth stuff to do that. What else? I will want to monitor output and input maybe. Well, we'll do that on the fly. I'll just plug these in as channel 1 and 2. Did that with a MIDI volume controller I sent to a friend 2 years ago, still waiting on it. I don't mind stuff like that. Obviously, I accepted the M303 from this person who was fully willing to just let me have it. But I gotta repair it. Be good on my word and all that. Same thing with Dave. Dave was like, whatever. So I'm like, look, man, it's like, I'm not gonna fix your shit and then keep it. It kind of puts you in a spot, doesn't it? That's all right, though. We'll have fun. We'll have fun doing this. It's good content. It's good repair content. This thing will be pretty cool when it's underway. I mean, I'll have my stereo mixer here that I can plug into some kind of an output that you guys will be able to hear. I'll figure that one out later. But then, well, actually, I already have it figured out. It's on the mixer. And then this, when it's complete, we'll be able to do a whole suite of testing. So I still have two fat PS3, two TWO, two fat PS3s that need to be fixed. There's a fat one. I haven't kept up with PlayStation and consoles in general. Are they making them? I mean, I guess they make thin ones. Yeah, you're right. So I guess the old one is then by default fat. I got Bubba Tubbs PS3. Big ol' fatso. Welcome to Saturday. I'm glad you guys are here. Those of you that can be here. Usually Saturdays are pretty quiet. How many? Oh God, yeah, the numbers are way down. It's just one of those things. I get a lot of viewership from people who are at work because my work looks like work. So, well, my hair doesn't look like work. I'm going full mullet back there. Holy shit. I probably need to get a trim. And by trim, I mean like a whole pound of hair removed from my body. Mostly my head. I'm looking a little. I'm starting to bridge the gap from homeless to Jesus. Wait, Jesus didn't have a home either. I'm thinking of supply side Jesus. I wish I could figure out this Node Red stuff because I'm so close. This is so close to working, and it just won't. I don't know why. Maybe I need to put some kind of a translator on the output of stream state change, because the same exact data coming off of these two works. When this does it, possibly that it's shooting the signals through so quickly. But then again, like, this doesn't make any sense. If I trigger two of these at the same time, it still works. And the bulb still gets a valid message. Whereas, as it is right now, where is that one? Like, up here. I'm getting invalid message received on input, even though it's coming from a valid location. Doesn't make any sense to me. And it would be stopped here if it was any exception. Would it? Yes, because I'm actually receiving the message. That's what the double is. The reason it repeats like that is because I was receiving on the input and output. Wait, what's this? Oh, that's this. That's a different message. That's a different message. Sorry, looking at the wrong one. It's these two. These two are coming from both sides of the contained starter stopped, and they are functionally exactly the same thing. Output true, quote, OBS underscore WebSocket underscore output underscore stopping, quote. Oh no, that's not for that one. That actually is one that went through just fine. But then the ones that was stopped is this one here. So on the output of the node, stream state changed, message payload, object, and the object is output active true, output state, OBS underscore WebSocket underscore output underscore started, in quotes, started, output state, output active, it's the same. It's the same message. So how is it invalid then? It's probably a little bit more complicated than just turning it on and off with the PlayStations. If they still have them and they're still broken, I would assume. Oh, you're not saying to turn it off and on. I see. You're saying more stuff than that. It's my stupid brain. My reading comprehension is below the level where I where I actually understand what the hell I'm talking about and respond in kind. I don't understand. So okay, I'm completely out on a limb here. You turn it on and it just turns off. Is that related to capacitor plague? My experience is like TVs and stuff where you have the friend of the TV that stays on for a certain amount of time and then it just, dies or flickers or does something weird like that. And you're like, oh, it's a capacitor. Just bring it in. Like, just bring it in. I've got capacitors. We can replace a couple of them and see what happens. And that ends up fixing it, pretty plainly. Or, it doesn't turn on, or it does one like blip and then it turns off. It's funny, 99% of the problems that we used to be able to predict, and the reason we all looked so smart back then, was that it was all just capacitors. It was all just bad capacitors. No, sir, I don't understand. I don't like it. I don't like it at all. Oh, so it was like the Xbox One. Wait, was it one or no? That was the 360 that had terrible thermal, not design, but it had bad thermal goop on it. Is there further debugging? I don't know. Current flow, I guess, is whatever's on the page. I don't know. I'm out of ideas on this one. I know it looks like I haven't tried anything, but my ability to suss out the logic of this thing has kind of met its end. I've got the exact same message coming into debug before and after the flow, and yet when I inject a message that should look and does functionally look exactly the same as a message coming from stream state changed, when I inject one, it works perfectly. Everything works just fine. Activated with a Twitch API call. That's what I'm going to be doing. I need to find that node again. I found a node that somebody had made that interface with the Twitch API. It has all the functions of the Twitch API built into it, and then I have a singular entry point for when the credentials expire. I just go to that, and then I can do physical, IRL layers of functionality with either Tasmota nodes or other types of nodes that'll do HTTP requests and things like that can make, you know, the little thing dance on screen. Or it can control OBS, or it can control like a Furby that we take over. We'll be taking over the Furby eventually. That's something down the line, but that'll be pretty cool because then I can have it do a little thing when the farts go off and all that. I put it on the desk here somewhere. The burning question for today's stream is whether or not replacing one singular op amp in this thing will fix it, because the output is not very strong. So we'll set up the test, we'll put it together, we'll give it a waveform and see how the waveform comes out the other end, and I will replace the one transistor, the one op amp, and we'll see whether or not that fixes the whole thing. I'll have to fix a dryer. Everything breaks when I go on trips. Almost made it through a week without the wife calling about something. Looks like the thermistor blew. That's usually, yeah, you got to find the thermistors that are all over the washer. Those things are great because they keep your house from burning down, but they also tend over time to go bad. That's basically a spring inside of either a thermoplastic or some kind of like wax whose properties soften when it gets hot enough. So if it gets significantly over ambient or significantly over typical operating temperature, that wax will get all gloopy, and then the spring is able to pull the contacts away from each other. And it's a one-use item. It's good to have a couple on hand. I have a couple on hand here for motors, just in case. You have a bag of them, happens so often. Yep. That's what happened to my old dryer in my old apartment. But then again, that dryer was a piece of shit, and the apartment was full of black mold. So that was when I got to live in the basement. I said, listen, guys, I have been living in basements like all my life, and I do not want to be in a basement. And they said, well, then let's put an incentive on it. So you pay less rent and we'll pay more rent, and you still live in the basement. And I go, all right. And so my, if you could call it a room, was also access to the laundry room. So I had no privacy. At least I'm not in a oh wait, no, I'm still in a basement. Why am I cursed? Why am I cursed? I should move to the West Coast, then I'd be in a garage. Of course, then my ability to do things during daytime would completely deteriorate, given that they are a couple hours behind us. Sounds like a lose-lose. I can't get out of this fucking basement. I don't know. Like, if a lot of people in my life suddenly die, maybe I could move my lab upstairs. But I'd rather have those people in my life. I really would rather. It's not so bad being in a basement. What was I going to get over here? Oh, yeah, I need a couple wires. A couple of these guys, these little mono plugs that I have. How many of these am I going to need? I don't know. I do not know. I'll just get a pile of them over here. Let's get a pile going. All right, I guess I'm ready to start. Doing stuff. Let's get the start soon out of here. And the music. A little bit more chill. This is a Aesop Rock instrumental. This one's Abandoned Malls, but the album Aesop Rock and Blockhead doing an album called Garbology. A lot of good tracks in there. I like the instrumentals because they're a little bit more backgroundy. I tend to like listen to the lyrics. So, yeah, what are we doing today? Well, you know, I'm waiting on circuit boards, and I've got one that should be getting here eventually. It's gonna maybe be it's gonna be in production a little bit longer. Obviously, the Chinese New Year, I believe, just ended. Or no, does it go till the 5th? I don't know. Either way, all the production lines that I know are not doing much until the 5th. The one circuit board for the mixer, that is in, that should be being produced. I don't know when I'll see it. I will get a notification that it is shipped. I'll probably tweet that it's shipped, and then in a couple days from there, we can then get to the brass tacks of the mixer project and put it together and see what kind of improvements we want to do on the circuit board. I still have to contact Fusion about my copy of Fusion Eagle. It's not. No, that's not it. It's just Fusion. Yeah, I have to contact my the guy on the creators team and make sure that my copy re-ups, or if there's something I need to do. Because I thought they would just monitor my account and go, bloop, yep, okay, he did his due diligence, let's re-up his copy. But now mine's saying I only have 30 days left, so I don't know what happens now. They're friendly and they get back to me very quickly though, so it should be totally fine. We will be doing some hashtag AutoCAD ad content. I was going to do a little bit today, but I kind of want to get some progress made on the module testing module. So the module testing module is, of course, where's my mouse? Oh, wait, I saw it. There it is. Okay. The module testing module is going to be the next version of this thing. It's going to be all this hardware just packed into a neat little PCB that's going to be about this tall. So there's some space restrictions are going to happen, and I'm going to be using the full-blown Teensy 4.0, so that'll take up a significant amount of the PCB space. It is going to be a beast to design. Once it's together, it'll probably have all kinds of problems with like crosstalk and you know, long signal paths and things like that. I'm going to try to keep it as like simple and easy as possible, but there's a lot of stuff that has to go into a very small amount of space. Once I get all that hardware done though, I have to program like a user interface for it, and I don't know how to even approach that problem. That's going to be a beast. But I want to get to the point where, you know, I'm like, this hardware's good enough, I can make this work for me, and then set up some like very simple test routines that I can do with it. That's where I wanted to bring back in the M303, but because we're waiting on circuit boards, and the alternative is me staring at a bunch of chips on a board and slightly rearranging them and going, that's probably going to be a problem later on. I don't want to have a stream that's that boring, so I'm going to make a little progress on that. We'll bring it back in at some point, and then when we get circuit boards, we can really hit the ground running and build that circuit and figure out what's what, because we know what is what, but we don't know what is what. We just strut. Yeah, but so the M303 coming back in, I have a somewhat functional frequency creating device that we can then plug into the M303 and figure out what it's going to do. In addition to that, I found that the output, I think, relies on one singular op amp, and that singular op amp is not giving us a lot of gain. So we can take a look at that op amp and see if that's what the problem is. We're at a bit of an impasse with these M303s. We've done a lot of reverse engineering. We've done a lot of writing of the circuit down. I am currently busy. I haven't worked on this in a while, but I'm putting the schematic into Fusion Eagle so that I have a nice computer schematic that's easy to read and follow and represents all the connections on the device, which is a beast to do to a circuit. It's quite taxing. I have a GIMP file. It's a image editing. It's the image editing. It's the GNU general purpose image. It's GIMP. They call it GIMP. Why did they call it that? Anyway, those fuckers. I can't talk about it in polite company. Anyway, I've been having problems with my GIMP. No, I haven't been having problems with them. Hey, that your fan. How's it going? Thank you for the sub. Saying hands up. I'm not looking for trouble. While it's in my back pocket, you can reach deep into it if you want. No, but anyway, so my GIMP, my copy of GIMP, how's it going, man? Not much is up. We're getting back to like old projects and stuff. There's always a lot going on, but I'm in that sort of limbo of waiting on circuit boards. So it's either that or work on Burn the Subs, and obviously I'm going to default to other stuff. I'm trying to get this synthesizer stuff like under my belt. I'm trying to get it done so that I can move cleanly on to doing Burn the Subs. Because the next time we work on Burn the Subs, we're going to continue to work on Burn the Subs until it's ready to go, until it does stuff. Part of that was, of course, setting up Node-RED and refamiliarizing myself with it, which is the stuff we were doing at the beginning of stream, where I was trying to figure out why, when a flow comes from stream state changed, or these two toggles that I've set up, they are the same exact thing coming out of both of these. Only this one fails. This one fails when it gets all the way to the light bulb. Whereas if I inject my own packet, it goes through all the same stuff, all the exact same stuff, and it does fine. It doesn't fail. I don't know why one would fail and the other wouldn't. Hi, RYG. I love hearing about burn the subs. We'll get to burn the subs, all right? I know I've been kind of cross with people about burn the subs, but it's one of these things that people keep reminding me about that I don't need to be reminded of, because it was the entire reason that this channel did so well. It's why we're partnered and all that stuff. And it's how I get my fanfare. When Burn the Subs goes back up, I wonder if I can goad some of the bigger streamers into raiding our channel, you know? That's usually a nice little draw. It'll come back, you know. I am going to work on it. But first, I really want to kind of say that I did all that I could do with the synthesizer stuff. So, anyway, yeah, I'm having trouble with the Node-RED flows. That is part of Burn the Subs. Burn the Subs, I'm moving the front end to the whole Twitch interactivity layer of the channel. I want to move to Node-RED because it's easy to visualize, and it also is pretty much made exactly for what we want to use it for. I want an interface with something, and I want that something to be able to do complicated controls of things around the shop. So if stream's active and, you know, this and that and the other thing, then if somebody does a channel point reward, make the Furby do this and set off a fart noise. I will be able to do that in Node-RED, and it'll be a little bit easier. And when the credentials expire, I don't have to open up a file that I haven't seen in 6 months and figure out exactly what number to paste where from what website and how not to dox myself. No, all that stuff can be in Node-RED, and I can just do it once. The water heater coil burned out. That sucks. Those coils are not cheap. I bought one for home brewing. Would you sell a poster of the old Burn the Subs board? I should. I really should. I don't know quite how to do that. I don't know quite how to approach that problem. And maybe when we get the new one working, I can figure that out, because we do have the ability to export images and create even vector images of the board. Dryer coil. Oh, that's the, sorry. I thought you meant water heater coil for some reason. I was in the middle of talking, so I obviously am not thinking on that frequency. Time to yerk it back together while ordering it. You go it on your own time. Whatever you need to do in your basement, your creepy basement. Okay, so there's 2 R's in jerry rig. Maybe chat GPT. No. 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 All right. Yeah, so anyway, the Node-RED, this is supposed to be sort of paving the way for me to do Burn the Subs on Node, and that'll give us like a significant portion of the functionality of Burn the Subs in kind of an easy interface. And it'll also, I'll be able to put like censorship, like a censorship engine into Node-RED, or I can have like the big Staples easy button, and I can just boom, hit the button, and then that'll send a name over to Burn the Subs. That could be a thing. What happens in my basement stays in my basement, and typing on phone while arms deep in the dryer is not easy. You are inside of an electrical appliance with enough torque to hurt you and enough volts to really hurt you. Why are you on your phone? You can give us an update later. I would be happy for it later. Maybe not while your arms deep inside of a control panel. Should I unplug it? Yeah, haha, I know you unplugged it. Okay, so anyway, I don't know why these flows are erroring out, and this is part of my inability to do Node-RED. I don't know what the hell is going on. What you see before you is the test that's going to run when I stop stream. When I stop stream, a message is going to originate from stream state changed. That will be listed on the debug output, and it's actually going to be 2 rapid succession messages. One is stopping, and the other one is stop-ed. I have this thing set up to detect either of those states, and I know they work because when I inject it with a packet that looks exactly like that message, it goes through and the flow works fine. Only when it comes from stream state changed, it runs into an error at this node, at bulb 1. Why would it run into an error all the way over here? If it's an invalid message type, the payload should have been changed at this juncture to be message payload as the signals that we know work. So why is it different? So I'm gonna key into 3 points at this thing, actually 4 points. One is the message on output. The other one is going to be the message on output of started or stopped contains whatever redirection. The other ones are going to be at the output of both yellow and green to see if a proper signal is coming out of these. What is leaking out of my system? I had this set up before. Everything looked totally fine, but I'm going to clear this. And when I'm done streaming today, I will be able to have that data point because I just simply cannot figure it out. And Leb TV Live has the right to have a life outside of my stream. So we can't, I'm not going to bother him. He volunteers his time to help the bullheaded American learn how to operate the simplest of child's plaything programming devices, aka Node-RED. He's a very patient fellow, and I don't really want to stress him out. So I'm going to run this test. Hopefully it'll be illuminating both in the light and my understanding of what's going wrong in the system. From there, when I get this working, the stupid on-air light, we will have a 3D design project for this, but we will also have my sort of initial baby steps into doing more complicated stuff in Node-RED. With that comes more status lights, but also the Twitch API node. I'll bring in the Twitch API node, get that all programmed, get that all registered as a robot, and then we'll be able to play with that and have you guys do stuff with channel points. That'll get really fun. We'll have a lot of like user stuff to do. Yes. I headed that one off at the, people think that I'm incredibly clever because I do stuff like these little puns like that, or the little language things that I do. The thing is, that's live. Like, there's no premeditation about that. I didn't say, I'm going to do an illuminating pun here. I was talking, and the next word I was going to use is illuminating, and I've learned to sort of catch myself. Oh, wait, that's going to be a pun. You should make it seem like you thought about that. And there are times when I don't do that, and my smarter friends will piece together this really intelligent joke that I didn't mean to make. And I'll just take credit for it. I'm not above taking credit for something like that I didn't actually mean to make a joke about. And they go, wow, he's so smart. And I'm like, I'm actually very dumb. I don't know if anybody's told you, but I'm very dumb. All right, so back to the problem at hand. I was sent an M303. Well, I was given an M303, and then I was sent an M303. And these M303 modules all have the same problem. Now, not to go over the same data over and over again, but those of you who are unfamiliar with the M303, the 303, the TB303, is an acid house synthesizer. And the reason that it's acid house is because those acid house fellas got a hold of these fucking things and they didn't let go of them. It is the signature sound of acid house, the types of squeeps and squelps that this 303 makes. You can make an entire song with a house beat and just doing this, right? If you listen to some Chicago house, some acid house, you'll know it immediately. Just throw on Carl Cox and you will get an amazing amount of repetitive house that has the squeeps and squelps of the M303. Well, acidlabs.de said, hey, this modular synthesizer stuff's pretty cool. You can sell a module for a lot of money and you can make a little bit of money off of that. And since we are clever Germans, we can make that signature M303 sound. And they went and they opened up a parts catalog and they said, oh shit, you can't make that signature sound. A lot of the parts that went into the TB303, by the way, there are repair manuals for the TB303, so they had a full schematic when they started out. It was an 1980s schematic, but it's still a full schematic. But, whenever they were making the M303, open up a parts catalog, none of this stuff is available anymore. Not to mention the fact that if we were to build a true-to-life 303, it probably wouldn't fit in the cabinet, in the modular synthesizer rack size. So what Acid Labs decided to do was to put together a circuit that is pretty much a true-to-form 303, but it uses more modern parts. I'm not going to say modern parts because they definitely are not modern parts, but it uses more modern parts to do all of the same analog synthesizer tasks. Now, digitally, obviously, you can just go on a website and you can have a 303 sitting in front of you, something that sounds exactly the same. It just does things digitally instead of analogically. But with modular synthesizers, in a way, it's a little easier to do things in analog, and it's cooler, and you get all of the weird drawbacks of doing things with analog. You get noise, and you get, signal weirdness, and all that fun analog stuff. I do enjoy me a good analog circuit. So anyway, the the gents, and I guess probably ladies too, or maybe it's just one person. I think it's one person doing this. But they put together their design, and they decided that, you know what? I'm not going to pay for a bottom layer silk screen. No, instead, I'm going to spend my time putting a little smiley face into the copper, and I'll expose it so the little smiley face is visible. And then I'm going to put a part number on the bottom. You know, I'm going to do 3033 modular SMD version 4 final 2 dot finished. The only silk screen that made it to the bottom is the 94V0 and other standardized markings for circuit board production. These markings are in reference to the fact that it's Underwriter Labs certified materials, which has, like 94V0 has to do with how this thing burns. When it burns, does it drip flammable liquid, etc., etc., etc. So the bottom layer of the PCB has no significant silk screen on it, which is often a little bit of a problem in modular synthesizer modules. You see, if you are not familiar with modular synthesizer modules, these are all connected with an IDC cable, an insulation displacement cable, IDC, and that's your standard square 0.1-inch spaced header. The challenge of the standard square 0.1-inch space header is, how do you plug it in? How do you plug it in? Well, there's some key features to one of these square headers that are rather important for the functionality of the square header, because you don't know what kind of signals. These things can handle up to 1 amp on a pin. 1 amp at varying voltages, probably 12 volts, 1 amp would be pushing it a little bit, but they can handle it, right? They can do pretty well for that sort of thing, and they can take a lot of signals from board to board, including including power. Power can be a little bit demanding, but since we are just wibbling waves, we're not moving speakers, you know, a little bit of power goes a long way. These synthesizers typically have the modular synthesizers. The rack typically has to power a lot of devices, and so you will have pretty large amounts of power sitting on the rails. So there's enough power to kind of do some damage. Not significant. You're not going to kill yourself by licking it, I should know. But, you know, you are going to kill electronics by plugging it in wrong. So the IDC cable, in its infinite wisdom, has a few key features. There's a little cutout there, and there's a little keyway. We call this a keyway. It's a keyway because it only plugs in one way. So you use a shrouded header of the appropriate number of pins, and that plug only plugs in one way. If I go to plug it in the other way, and by the way, it does plug in the opposite way, but only if you are one of my friends and you have no respect for the engineering of this thing. So if you plug it in, I need more light over here. Hold on. Microscope, get no damn light. Shadowy ass, microscope ass, view ass. So if you try to plug this thing in wrong, it generally doesn't plug in. Unless you really, really want to plug it in wrong, in which case, this one is not cooperating. You can kind of move that plastic and then it'll plug in. And then you are completely responsible for what is about to happen to your electronics, because the way these modular synthesizers are designed is not to have this thing plugged in wrong. Now, people do what I do and they put diodes on the inputs. And that is sort of our only line of defense. If things plug in backwards, those diodes will block in that configuration. If you plug it in sideways and discombobulated, well, then you're in trouble. Now see here, I've actually keyed into another feature of the IDC cable, the stripe. Now in some designer circles, they don't have gray IDC cable. These are all, the displacement is all connected to each other in the middle. Each of these has a little wire in the middle, and then this plug itself interfaces with that by being a type of vampire clip. A vampire clip is literally what's on the tin for IDC. It's insulation displacement, right? All it has is just a little metal clip that the wire presses into, and the little metal clip will push the jacket out of the way and interface with the metal. Love IDC, hate the key, try to remove a pin and block a pin. I like IDC because you can put jumpers in here and it uses standard header cables. So sometimes you build a module and you don't have space. Sometimes you build a module and you don't have space to put a shroud around your connector. Sometimes you just don't put a shroud around your connector, which I think is wholly irresponsible and probably should be against the law. But sometimes you do that. So, okay, fine. We won't put a header on this, and we're going to put our own proprietary header, which is very closely resembles the IDC of modular synthesizers, but we've added a few internal signals to it. That should be fine. You can still plug in a standard cable to it. The only problem is, the other feature of the IDC, the one that I haven't mentioned yet, is that there's a little bit of space on the edge here where there is no cutout for a pin. And so if I were to try to plug this into the wrong thing, it doesn't plug. This will only reliably, I mean, I could force this and it would bend some of these pins out of the way. The only way to connect is to have the right number of pins or have a cutout on the pins. Like if I removed those 2 pins, I could probably plug this thing into the side like that. So if we forego all of those safety features, we would be working for 3M. 3M made what I believe to be an evil connector. I think 3M, like, they're just sitting in a dungeon and they're like, how can we be more evil? And they're like, well, it would be really evil if we made an IDC connector that forgoes all of the safety features of the IDC standard. We should do that. I mean, at the very least, they at least gave us a little arrow to indicate pin 1. That's another feature of the IDC, right? I keep coming up with these features. There's an arrow at pin 1. So pin 1 over here, and it's always going to have that arrow. Pin 1 also has a stripe on the cable, and that stripe is going to indicate pin 1. So one of the things that we do is we label which pin is the stripe pin. So I have stripe here. There is an arrow. There's actually no arrow there. The arrow might be, actually, I think the arrow's right here. I put stripe on the wrong place. I had this upside down because I was viewing through the board. Luckily, that was fixable by just turning the connector around. But either way, yeah. So we label where the stripe pin is. That label should probably be over here because this is an error in my design. Oh no, stripe is definitely over here. It should be up here. It should be up here. And my dot marking for pin 1 should be on the other side. Those are corrections that we have to make in CAD. But the point is, I've got the shrouded connector, so I can't plug it in wrong. Supposedly, I've seen it done, and it has to have the right number of connectors. Well, Acid Labs decided that they wanted to have their own sort of like daisy chain connector-y method for their own synthesizers. This thing was made at a time when there was still a little bit of contention about the standardization in modular synthesizers. So they decided to go out and get this 3M plug that was created by Satan himself from the fires of hell. This thing was made of brimstone and ash. There we go. And it's made just to be evil. It has a cutout in order to allow you to plug this thing in to any position of the IDC cable. It does not have a keyway on it. It only has an arrow for pin 1 and a stripe. How's it going, Sudabe? So in order to plug this into the Acid Labs style of daisy chain interface, you do not plug it in the center as might be indicated by the shape of things. You will look and you will find that there is no marking that tells you stripe. Nothing tells you stripe should be there. If you plug this in wrong, you will end up plugging multiple volts up to 24 into your ground or into the wrong direction or into a signal that it shouldn't be plugged into. Lo and behold, a group of people who aren't responsible on the detail level that engineers are, musicians, wind up plugging this thing in wrong. In fact, this pin over here, the stripe pin, is supposed to be at the bottom of this, which means you do not plug it in like this. You plug it in like this, off by 2 pins. And you will find in all the literature that they try to warn you about this. You plug it in, offset, 2 pins. By God, if only they had room to say stripe or to shroud the connector. I mean, you know, it's a stripe or -12, +12, or... But they simply did not have room to put vectorized text on the bottom copper layer, and they definitely didn't have any access to a silk screen. Cut off block the extra pins. I actually offered for Dave to put a shrouded connector on this thing, and he didn't want it. He wants it to be original. So the death that all of these suffer is when you plug it in like this, or any permutation thereof, because this cable allows you to do that. What you're supposed to plug in is that pin 1 to the first header. So it needs to be off by 2 for it to work. Yeah, it kind of changes the nature of the smiley face they put on the bottom layer, doesn't it? So faced with that, we actually were able to find a document. It's a GIF for some reason on the internet of the main, whoever's doing all the repairs to these things, made a document that shows exactly what you're supposed to replace. I'm gonna have to get my glass of water in a little bit, or fill my glass of water in a little bit if I'm gonna keep burping like I am. I had supermarket sushi for lunch. Supermarket sushi. Anyway, there's a document online from the designer of the circuit board of the M303 because they had to repair so many of these that are broken in exactly the same way. And it says, replace this part, this part, this part, this part, and this part, all at the same time. And if you don't do them all at the same time, it's possibly that they could cascade fail the other chips in that line. And these are the ones that blow up when you plug it in wrong. Well, we went to trying to repair Dave's well before we found that document. And so I looked at a bunch of stuff on the board and I powered it up multiple times, and I actually desoldered the headers so that I could flip them around to the other side so that I could work on the circuit board while it was powered on. We learned a lot of stuff about ourselves and the M303, and then at one point I plugged this thing in wrong because these two headers that hold this thing, that hold the front and the back panel together, these are moderately asymmetrical. So if you flip them over, it almost kind of plugs in a way that makes sense. It's just the mounting holes don't line up slightly. There's another piece of the design of this thing that is just hostile to the consumer. And I don't think they meant for it. These are pitfalls when you're designing a big system. These are all pitfalls that might not be readily evident when you're designing a system. We can sit here from the sidelines, look in on it, and go, man, that makes no sense why they did that. But I mean, you get the blinders on when you're designing a circuit, right? You're like, and also, you know, German sensibilities. You know, speaking to people who are German, you go, you know, you can cross the street there, and they go, no, it is impossible. It is against the law. You know, that's kind of, it is not possible. It is legal. So they might not think from those angles, like maybe we should make this foolproof. Maybe we should make sure that somebody who knows what sounds good and is on a lot of drugs, like maybe we want to kind of like foster them into doing things correctly, instead of relying on some eclectic document in a filing cabinet in a basement to tell them exactly how to plug in this device. I mean, I know they put it in the manual, but I don't see a lot of musicians sitting there and looking at reading the manual. Oh yes, no, they don't do that. The whole modular synthesizer system is designed so that you can plug whatever the hell you want anywhere. You can put audio into a CV and it's not going to blow your device up. I don't understand why the failings of that, like why do they stop at the front panel? It should also, the back panel should also represent that. So anyway, recently took apart a module in an Amazon robot that I got, fell off a truck. Anyway, the board, nice. The board had these super awesome illuminated buttons. Part number is, I'm considering using them in my designs, K5ATWH3GP. I still hold to reason that the best button that I've ever used is the crystal light pipe from Adafruit. That was one of the best buttons that I've ever used, is the crystal light pipe. Because you do the light pipe on the front panel, and then you put a tactile switch on the back. So readily available parts, easy to find, and then a 3mm LED is at exactly the right height to get the light into the light pipe. And the light pipe is designed so that the light bounces off of some of the shiny parts and goes directly down into the end, which has this beautiful, what is it? It's like a textured surface. It's this wonderful, like, not crocodile skin, but like a orange peely kind of texture to it that just makes gorgeous light. I used some of the most precious LEDs that I ever had, which were deep purple. Deep purple being the color of the Volkswagen Mark IV dashboard illumination. That was done with deep blue LEDs. They were early blue LEDs that weren't the lighter blue LED. They were like a deep purpley blue. Oh, so good. So I used one of my precious ones for the fire cannon controller in one of those light pipes, and it made this beautiful, beautiful glow. Yeah, I've got to find, I got to find some of those LEDs. They're like I've been chasing that dragon. I've been looking for, they're my white whale. There we go. White whale chasing the dragon. They're my blue dragon. I don't fucking know. Anyway, I gotta find them because they were like shaped like this. They were that like Star Trek nacelle shape, and they were little like almost 3mm LEDs that were slightly tinted blue, and they had that perfect deep Volkswagen blue color to them. It was like an LED replacement for a lamp in the VW Mark IV. But yeah, they're beautiful illumination. This looks like just an RGB or white LED on the head of a button. That's pretty cool. $12! Holy. Jeez. I'm sure that looks great. If for $12, it should be doing my homework. So yeah, we've got documents about why this M303 should work. We've got 2 of these boards, the second one being broken in exactly the same way without the unfortunateness of me plugging it in upside down. Stupid thing. $740 if you buy 250. How's it going, Hairbrain? Good to see you in stream. So, yeah. The M303. This thing is busted. We have 2 of them. In spite of my shuffling about and plugging this thing in completely wrong, both of the units that we have are broken in exactly the same way. I've replaced the same components in both of them. For some reason, Acid Labs, like they were trying to, all the work that Acid Labs did in order to design the M303 board, they wanted to kind of protect it from all the shitheads like me in the modular community that would as soon reverse engineer your circuit than actually call you and like, instead of buying one, I'll spend 10,000 hours of my life reverse engineering it. I'm like that. That's what I'm like. So what they did is they sanded off all of the identities of the components. Now we have that. Ow, that really hurt. I just put my screwdriver in. It's like me putting the screwdriver like this, and watch me make it disappear. Watch the screwdriver disappear. Oh yeah. Thud. But yeah, anyway. So we have 2 of them that have failed in exactly the same way. Luckily, that means that I didn't further blow this one up, but we don't know what has failed because I did the repair, and we have some of the identities of the chips. Other ones we've guessed based on pinout and the knowledge that my chat has of modular synthesizer circuits. Now I have that knowledge. I'm up to that level now. I know that there are certain like fixed circuits that people like to use in these things. The voltage controlled, the transconductance amplifiers. Man, transconductance makes me think there should be like an orchestra called that. That'd be awesome. They spared no expense on this module, and it had 2 identical RF circuits. Weird. Why are they doing design with stuff that's that expensive? I guess maybe it probably has a ton of cycles that it can do, right? It's probably a very strong switch. It's $12, man. Whew. I guess if you're Big Daddy Amazon, you're going to be making a lot of these robots. All right, so anyway, we have 2 of these that have failed in a particular way. I've done a little bit of reverse engineering on it. We know somewhat of how the circuit is working. We know a little bit of how the circuit is laid out. But in my quest to repair these properly, I have nearly replaced every part of this circuit. Now, in terms of testing, we have this thing working and functioning perfectly fine, except that it's not outputting as strongly as I think it needs to be. The voltage just isn't there. And both of our modules are doing the exact same thing. They're both not outputting on the main output at the right voltages. We don't have the amplitude on the main output. Amplitude. Welcome to my Philadelphia accent. If you guys are familiar with what happened last night in Philadelphia and you were listening to the police scanner, you know what all the spectrum of Philadelphia accents are. It was pretty awesome to listen to that police scanner. Man, I can't believe that jet that came down like a lawn dart. It's crazy. Anyway, so these robots look like little Roombas. Yeah, they're the ones that move around like shells and stuff. The Hercules, the module I got, had power buttons and e-stop. The e-stop was worn and broken, which suggests that it got used a lot. Who's emergency stopping all the time? That's crazy. That sounds like a cool thing. I wish I still had all the connections that I had to get stuff to take apart, because, man, that would be a fascinating disassembly. If you could take a picture, I would love to see it on the Discord. So, yeah, anyway, we've been repairing these modules, and it feels like I'm treading water with these things. Everything that I do just does not seem to affect the output in the way that I want it to. I'm very familiar with this circuit. I'm looking at all of my old friends here. We took a picture of the front and the back of the circuit board, and we overlaid it on top of itself in GIMP. And I was able to trace all of the traces in GIMP. And then I also removed all of the chips on this board. Dave's module has done quite a bit to help us along with this. I've figured out what traces are under these chips. I know where all the traces go. I know most of the circuit. I don't have it all down yet. There's a lot of stuff that I still have to kind of figure out on this in order to get a full schematic of it. I should not have needed the full schematic, but it seems like where we are with this thing, it seems like I do need a full schematic. So what I want to look at today specifically, and it's taken me like an hour to explain everything that's going on here because this has been a long and circuitous project. What I want to do is I want to remove one particular item and replace it. And it turns out all these chips, all this buffering, all the resistors, all the capacitors, all this output stuff comes down to one single op amp right here. This one, C397, is a single op amp package. I replaced the original one with a similar one, and it didn't work. So we're going to get this one out of there, and then we're going to actually put the correct one into its place. So I got to find the chip before I remove the old one, because that one performed in exactly the same way. And I have a feeling what's going to happen today is I'm going to go through all the effort to remove this. I'm going to put in the new one, and nothing will have changed. And then I will cry. I will openly weep. Because we've tried a lot of stuff and not a lot has worked. These synthesizers are always like that. I always go well above and beyond the Call of Duty to try to repair them, and then it turns out like something else weird happens and it totally invalidates all the work that I did. With the reverb module, we went through similar, where I went through all the steps to reprogram the microcontroller, and I had it working 99.999%. The only thing that I didn't do was output a clock on one of the pins. That was that last little bit, and then it turns out I could just reflash it with the code from another one that Julian had. Okay, none of these are what I'm looking for. Where did those go? Oh, maybe it's this. Yeah, it's this one. I bought some direct replacements. Yeah, here they are. So these have the part number of the original one on them, not C9397. These are a different op amp. And so perhaps we can get, oh wait, C397. Oh, you know what I did? I swapped this one around. I think we swapped it with a different one and it didn't work. So we put in the original back until I could get new ones. Anyway, I think these will fix it, maybe. I really hope. I really hope these fix it because I'm so done with this thing. You know, we know how this thing works, like down to its bones. Today would be kind of a fun thing because I don't need to think a whole lot. I don't need to do a lot of thinking today. We're just going to replace this part and see if it fixes it. And if it doesn't, it's possible that I want to get a little bit further with my module testing module before I bring these back so that we can actually characterize what's going on and have a way to quickly get all the signals out of it that we need. Because I don't know, I need a trigger and I need like a waveform, and I don't have a trigger set up on the module testing module, but I can set that up pretty easily. All right, so we're getting out this little SOT 235 chip. The big blade iron, I think, is all that I need here. Now, you know, I've had it out. I've had discussion. I haven't had it out. I've had discussions with people on the Discord about these tweezer soldering irons that everybody seems to love. It seems like after a certain amount of time, after a certain amount of like people that are new come to the stream and watch me for a little bit, they go, man, you should really get one of those tweezer soldering irons. It happens like with regularity. It's so weird that this is like a phenomenon, but it's something that happens. People will suggest that. And I have never seen a set of tweezer soldering irons in any of the many professional electronics shops that I've worked in that have been used. Have you heard about those awesome tweezer soldering bands? I've seen them collect dust. That's all they do, because it's this specialty item. You know, you got to take off your regular iron tip, put this thing on, let it heat up, make sure the two tips are doing okay, and then it's this big wonky piece of plastic that you have to maneuver to whatever surface mount thing you're trying to remove. I mean, I guess maybe if you're trying to quickly get rid of surface mount, or not surface mount, through hole and surface mount chips, maybe. I could never get the Metcal ones to work. Yeah, and there's a lot of parts that can break. And yeah, you can switch to hot air. You can use chip quick. You can just load the chip up with a bunch of solder and just bounce between pins and get the thing off that way. Now, you know, you guys have seen me struggle with all those methods, but I don't have to like change the whole iron. I don't have to, yeah, the chisel tip, believe it or not, a big fat chisel tip can do some of the smallest work in soldering. I've not seen those tweezer soldering irons used. I've seen them. They'll, you know, put it on the budget. It's a $700 thing. You plug it in once and you use it and you go, this is just as awkward as using a regular tip. Why would I switch all the way to this thing? So that's my experience. And obviously I'm not going to dissuade anybody from getting the big tweezer set of irons, especially if it's $10. But if you're looking to spend $400 on one, let me save you the time. Don't do it. Simple gets you there. So I've got the big chisel tip on this thing, on the quick change tips. And what I'm going to do is I'm going to load this thing up with new solder, because the solder is looking a little bit dull on that chip. It may not have been refreshed. I might have done the chip swip on the other 303. Dave's 303 is the one that I can like manhandle. I want the other one to survive. Conical tip was invented by a bad man. I like the conical tip. I use it for some stuff. But yeah, the chisel tip is usually the workhorse of any competent soldering setup. Can I do this with the board just floating like this? I think I can. I could tape it down, because this is bigger than the vise. So I could tape this down, or I could put it into a PCB stand. I need to get one of those like low flat ones, the low flat PCB stands. But I think we can just work with this thing loose. And I'm using the big solder because I'm going to load up these 3 pins simultaneously with solder, and then I'll flip over to the other side and do the same. I'll load up those 2 pins. And so here I can heat up an entire side of this thing at once. And we don't worry about the excess solder. That extra solder, what that solder is doing is that it's coming in here and it is alloying with the old solder, and that brings with it some of the flux from the rosin core, as well as sort of a non-crystallized, formulation of metal. It allows us to refresh the old solder that was there and keep it from preventing us from removing the part. You see how easy that was? It was just bouncing from bank to bank with the super extra. So now we've got all that rosin sitting on the board already. We don't need to introduce tacky flux. Tacky flux is it's one of those things. I feel like a Morton Joe saying, do not become addicted to water. But seriously, people become addicted to the tacky flux, and it's bad. It's an affliction. The rosin core in the solder spool itself is good enough for me. Now you can see what I was doing there is pressing down on the solder braid and heating through it to my surface mount pads, and then sweeping away. I'm sweeping away because I'm not pulling away, because if I'm pulling away, there's a chance that I leave behind a little bit of solder on there, and it solders itself to the braid, and then I end up pulling the pad off. These are surface mount pads from an unknown board manufacturer. I don't know how well they're held on. And if you guys were there for the last stream where we looked at those 1980s test equipment thingamajigs, those test equipment racks, we know that sometimes the interface between the copper and the FR4 board is really bad. I went to unsolder the number 8 because it had solder all over it. So I was just going to press this down and get it out of there. But apparently 666 degrees Fahrenheit was enough to lift the entire thing. I just rip off the pads. Yeah, really. And there it is. The pads are gone. No, so anyway, here's our SOT235 chip removed. Now we're going to put in the new one. And I don't think I'll switch tips. I can do this with a chisel tip. I'm not going to do it all at once. We're going to do one at a time. But what we do, we will solder one pad down as an anchor. So I'm going to actually get the thin solder for this because I don't want to totally overdo it. If we were using hot air, I could pluck the part and probably put the part back down and it'll be fine. But that was relatively new technology in the 80s. Yeah, really. Yeah, that pad did not give it didn't put up a fight at all. It just left. It was gone. Not fun to do on a one-off board. That's what bodge wires are for. That's what friends are for. So come down here, and I'm just putting the corner of this onto that pad and melting the solder to that pad enough that I get just a little bit of a bulge there. Dryer is temp fixed. Isn't that every fix? Every fix is temporary. And remember, this is only temporary, unless it works, in which case it's permanent. I'm just going to peel up this little little protective plastic, get one of these chips out, and get one of these up. Yeah, dang. These aren't great at gripping. They're good at holding stuff, but they're not like grippy tweezers, and they're getting kind of old. I may need to replace them soon. C397. All right, same chip. Do you ever run into components that you can't desolder first try? If so, what are some other methods of desoldering components? I'd have to run into the cases in order to give you good advice on that. But there are a lot of different methods to desoldering things. One of the big ones is there's a desoldering metal. It's called Chip Quick. You got to make sure if you're buying it that you're buying the right Chip Quick, because Chip Quick also sells solder paste and stuff. You got to make sure that you're buying the relatively expensive, I think it's bismuth stuff. And what that does is you add it to the solder and it lowers the temperature that the solder stays molten. And that can help you get over desoldering sort of, big things and surface mount things alike. Problem is I haven't anchored the board down, so I'm trying to move this while also keeping the board from moving. I don't really know if I'm exactly on top of it. What I'm going to do is put a finger down on the board, heat this up again, but then press this directly downwards. Not as to like shuffle it around on the board, but I'm trying to just get that pin to be flat and all the other pins to be flat with it. So that's down on the board, and I've got my anchor pin in place. I'm still using the big wedge because I'm too lazy. Yeah, I mean, I'll come up, like, as I work stuff, these different methods will come up, and I like to try different methods to desolder things. If you've got something like a big chip, you can also sometimes put a solid piece of copper wire down on that and then add a bunch of solder to it, and that way that'll transmit the heat to all of the pins. So if you do that on both sides, you can jump back and forth and the whole chip will fall away with it. These, though, at this size, I'd probably want to use hot air. Hot air is sort of like the I wasn't asking method of removal. So it always works pretty well. Yeah, the fixes are temporary until it breaks again. My shadow is getting in the way. Hold on. I don't have an illuminator on the microscope itself because I don't like that. I like having my 3 points of light so that I can show you things on the desk and they look natural. But it does cause an issue when I'm soldering something so low. Usually something I'm soldering I'll put into something else, in a vise. And the vise gives it a little bit of momentum. It gives it a little inertia so that I can push on things with the iron and I don't move the board. That's not soldering. Hold on. That might have fallen down. Yeah, okay, so it eventually did. We're looking for what's called a wetting, W-H-E-T-T-I-N-G not W-E-T-T. Wetting, which even though it's not wet, it looks moist. It's a weird word. But what I'm looking for is for the solder to flow over everything and not just the pin or the iron. I have enough heat with the wedge. I'm kind of struggling to use the wedge here. I think some of these parts were holding up my... Like for instance, the joint that I just made was really bad because I let the solder fall onto the pad. What I should be doing is heating the pad and adding the solder to the pad. Sometimes I like to come in behind the pin just to make sure that everything gets solder to flow on it. And there we did a little impromptu drag soldering. That's not my proudest work, but it is on there, and everything is making a connection. Oh yeah, I've watched a lot of that stuff. I've watched a lot of those film reels. There's a lot of good advice in them, actually. Not a lot has changed in the techniques and practices of soldering in the years since the 1960s. The 1960s. Yeah, not a lot is... what temperature am I using? 666 degrees Fahrenheit. Yeah, those old film reels are really good. If you're looking to learn soldering techniques, it's good to look at those. What is it? AV Geeks on YouTube has a lot of that stuff. A lot of electrical stuff recently too that I've been sort of perusing. There's some good advice in there. There's some stuff that's dated, but yeah, there's nothing about surface mount because that hadn't really been invented yet. When did surface mount first come about? It was after they found that UFO in the desert, right? We're ready to test this. I'm ready to test this, and unfortunately, I can't jump in on parts of the circuit. They decide to do this kind of stuff in modular synthesizers because they love to put the electronics in a place where they can't be damaged. You know, you can't brush this up against something and really damage your electronics. So they do it this way. 2022, 23, 24 heater coil, Amazon orders. What? Something else is wrong there, bud. Something else is wrong. Yesterday, I got a M303 DSO scope multimeter for $7. The scope part is blown up, but the multimeter works. That's cool. Scope part used an off-the-shelf ADC. The chip is $10. Wondering if I should bother replacing it on a $100 scope. 1/10 of the value to replace one chip. Yeah, that's interesting. Post Roswell ICs, yeah. No, the what are we talking about? C Strachan is talking about a heater coil in a dryer. Was it a dryer or whatever it was? Dryer. The output temp is off and it goes hot full time. Maybe you need to replace that temperature sensor instead of replacing the coil every year. All right, so what I'm going to do is I'm going to plug this into my modular synthesizer testing module, and what I have is two banks of power plugs. This bank of power plugs goes through my milliamp meters in the front. So if anything goes wrong with this, I will know. I also am going to heed that the stripe is there. So I'm going to plug this thing in like this. Now this module does not use 5 volts. It can, but it doesn't need to. It has a 5-volt regulator on it. So I could solder in the smaller modular connector and it would be totally fine. But again, Dave doesn't want any alterations done to his modules. So, well, the second time I had to replace the heater, maybe the third for me, I would be looking at that temperature sensor. Not like the 4th or 5th time. That's crazy. You're crazy. All right, so we built this thing from the ground up to be a modular synthesizer testing stand. I haven't quite completed the frequency. Well, this is a 6-frequency generator, not a receiver of any kind. The one that we are going to be putting onto the circuit board is going to be a send and receive. So it'll have all of the functionality that we need for this thing to not only calibrate itself, but for it to create all of those wonderful outputs and then measure the inputs with some semblance of measurement to it. Now, it's not like any of these traces are going to be professionally laid out So there will be noise, there will be inaccuracies, there'll be all kinds of stupid stuff happening with it. It'll be good enough, though. It'll be good enough that we can test a few things that we build, and then I can build more modular kind of stuff and get my actual modular setup working. Because that's been a thing that I haven't, this is just feedback through my hand. I haven't had the thing working. I haven't been able to do anything with the modular synthesizer setup. I need to focus in and finish a few of those modules and then actually be able to make sounds with the damn thing. But anyway, you know, we'll get there eventually. What's up, Famished Edits? Okay, so I have 6 signals coming out of here. I have the M303 plugged in. We're going to take a look at the milliamps when we flip it on. I need a power cord. We actually made this able to run off of USB-C because USB-C has 15 volts DC. 15 volts DC is a typical input to a modular synthesizer setup. So if I plug this sucker in on the power plug, turn it on, boop, we see milliamps are below 100 on the plus 12 line, which more than likely means that we're not blowing it up, although this voltage regulator gets pretty toasty. The actual version of this thing that I'm going to build, the working synthesizer tester, is going to have slightly better, a slightly larger LM1117 voltage regulator. So it'll still make a lot of heat, but it'll be able to dissipate it a little better. How can one get into electronics? You just get into it, man. No holds barred. Find something that you want to improve and improve it. Why are these voltages like wildly weird? Oh, because I'm adjusting channel 1. I want to be adjusting channel 2. And we'll bring that in. There we are. So, channel 2, we are reading, and do I actually have a measurement up? Oh yeah, we've got a 10 volt. And our frequency is 261, so I made it approximately a C note coming out of these things. Release the magic smoke. Oh yeah, don't mess with main. Listen, if you're getting into electronics, there is a huge world of digital things you can do. You can find something that you wish to improve. You know, like one of the projects that I've been doing is hooking up an LED bulb to my OBS and making it tell me when I'm streaming or not. This is an on-air light. I'm kind of struggling with it, but this is sort of the mentality of the projects that may keep you in the electronics hobby if you want to get into it. If you're like, I want to learn how something works that's broken, take it apart, take a look at all the stuff inside of it, try to get an understanding, and eventually you'll have enough knowledge to fix things. But, you know, you look up some more focused things about how something functions, if it's sort of a well-known thing, or you find something that you want to improve or you want to build that doesn't exist. Those are the kinds of things that like kick you off into a project. And each subsequent project, when I'm building things or coming up with project ideas, I always make it just a little bit out of my skill set, just make it scare you a little bit, just a little bit. Any project that's worth doing should scare you just a little bit. But anyway, when you get into actually building a circuit, if you get that far, don't listen to the old like project books and old circuit design stuff. Because like back in like 1970s, they were like, hey, little Timmy, grab a cigarette and come on with me. Let's get into electronics. And they go, here's a 1 to 10 transformer. If you put AC in one end, 1/10 of it comes out the other end. So why don't you plug that sucker into the wall and let's get going? What? I'm looking at my manual, like cigarettes, but also like they want me to plug this transformer directly into the wall without a fuse. They literally have projects that start with that. We are far and away beyond. This is the year 2025 of our Lord. We are so far beyond fucking just plugging shit into the wall. You know, people were harder back then, but they were covered in asbestos and cigarette dust and creosote. Listen. Start with 5 volts. You won't hurt yourself with 5 volts. Chester Willard can manage to hurt himself with 5 volts, I'm sure. But you start with like low voltages. We don't need to involve mains or power supply design in any of this stuff for a long time. Start with digital. If you find something you want to improve, or if you find something cool you want to make, or just follow somebody else's project. That's a great way to start out. Listen, I started in electronics in the early 90s when I was a little kid. So I don't know how to start off in electronics anymore. I don't know how to do that. Other people who are starting off can probably give you much better advice than I can. But all I'm saying is don't deal with mains. If you want to do stuff with like, oh, I want to digitally control this light, use a low voltage light, or find like an E switch or something like that. You know, digital stuff is very easy to get into. Yeah, you find a project and you just do somebody else's project, and that'll give you an idea of what goes on. Hey, Chester Willard, subscribing with the what is it? Peep poo poo poo. What is it? Peep poo poo poo. Does the people happy? Yeah, lead paint chips and asbestos, and yeah, I mean, man, they used to screw just like me. No, they used to screw electronics into cutting boards in order to create circuits. Like, we're not like that anymore, man. So yeah, find an Arduino project that does something similar to what you want to do, or find two projects and smash them together like peanut butter and chocolate. Of course, you want to add a little raspberry to that because it's delicious. But that's sort of like the Arduino project that nobody's done before is this project and this project with a few less of the frills, poke them together, boom, you've got something original, right? That's sort of a lot of cool stuff. Most people start off trying to fix things that are broken. My brother and I started off taking things that worked apart and producing broken things out of that. It worked the charm. It was great. We were, hey, how can we make a broken toy car instead of this working toy car? And by God, we were good at what we did. All right, so here I have and waveform. Here's a waveform coming out of my device. It's going through this cable. It's going into my oscilloscope. My oscilloscope is a $1,000 Rigol DH0914. The price has somehow gone down on this thing, which I'm pissed about. I could have saved $400. Anyway, it's going into that scope. That scope is Android-based, and it's on my network. So what I'm able to do is give you a high-speed window into the scope. You can actually log into this page on the intranet. You're not on my intranet. You better not be. But you could log into this and actually like poke stuff on the screen and change the settings and stuff. Pretty cool. Any of you just entering electronics, just getting into it, there are like $5 oscilloscopes that you can buy that do perfectly well. $25 ones. Digilant analog discovery devices. That sounds kind of cool. So, wood is fine as long as it's non-conductive and dry. I've had several motherboards screwed down to 2x4s back in the day. I put a computer into a microwave. That was a fun one. We had all of the circuit, all the motherboard was on just giant threaded rods. National Instruments bought them. Oh man, these I figure when I think about electronics companies, it's just like an amorphous blob. It's all like you know, like when you put oobleck on a speaker, and it makes these like weird figures that look like they're dancing and like morphing with one another in sort of this like insane hedonistic orgy. That's what electronics companies are like. Okay, so this thing is powered. We've got a waveform coming out of this. Oh, wow. Why does that do that? Why does that wobble so much? We can view our output here. Obviously, nothing is happening on it now because we need a gated signal into this. We need a gated signal. We don't necessarily need to give it a voltage, but with the volume up or down, we're getting nothing on the output. This is the yellow trace that we're looking at. So what I'm looking to do is find something that can function as a gate. So this is going to gate a lot. This is a it's going to hit it quite a bit, which I guess is fine. So we can use that as a gate. So which one was that again? That's a triangle. Yeah, so this will it'll hit it quite a bit. So it'll probably just be open, which is what we want anyway. So gate in from there. So now we are we're hammering away at that. So the voltage control oscillator, control voltage, the control voltage in, the slide in. We don't need any of that. The output from a voltage controlled oscillator, it is not looking very loud. I can of course change the tune. It does have the right shape. Let's VCF, that's how much the VCF affects it. That's not the right thing. Volume is for our main output, not for this bypass. Accent is for that. Envelope and stuff we haven't even gotten to. So this is right at the voltage controlled oscillator. We're not getting enough amplitude. What? I thought it was an accurate description. So we're getting 2.5 volts peak to peak on this. That is a problem. That's not even affecting, you know, any of this other stuff that's going on. It's no wonder we're not getting anything on the output. This VCO is totally quiet. Now, I can put the VCO, which one was it? It was, that's voltage controlled frequency control voltage. Voltage controlled amplifier in. So we can put our square wave that's at full amplitude into here. Oh, wait, no, I still need the gate. We can put another signal into it, though. We can put, like, our sine wave into it. Hold on, let's see. Which one's sine wave? What the heck is that? Oh, that's the magic one. Oh, and the sine wave is the magic one, where only if I put my finger... If I put my hand over this board, it works. Stupid fucking thing. I'm hoping that printing a PCB for this thing is going to solve that problem. Look at that. It's like the second I touch this thing, it's like a bad capacitor or something. Are there any electronics tools where you'd recommend skipping the cheap option and going straight for the more expensive one? Ooh, that's a tough one. Your chair. Don't buy cheap chairs. Your back is worth more than that. You want to have something ergonomic enough. If you're working at like your computer desk, get like an ergonomic chair. And you can get them secondhand from office places where only office people have farted into them before you. You want to get something that is, because you're going to spend a lot of time in your chair. Because let's be honest, you're a bit of a dumpy, doughy guy, and you're getting into electronics, for fuck's sake. You're going to be sitting down for a long time, whether it's reading stuff or soldering stuff or whatever, or cursing at a CAD program. Also, long live Acid House. Yes, the squeepy squelps of Acid House shall forever be in the halls of our... Anyway, you're going to be sitting down for a long time, so it is a good investment to get a good chair. I mean, just in general, don't buy a chair that is from a failed race car company who decided to put casters under their racing seat because they were too chicken shit to put it into a crash test. That's all of these stupid gaming chairs are like this. You're not going to be taking lateral G's while soldering stuff. I'm sitting here soldering stuff. I'm not like, I can't hold on. This is too, oh my God, I'm blacking out. Why do you need a chair that can support you during lateral G forces to play video games? Get an ergonomic chair. Look for them at office place resellers, because office places will start up and they go, we need the greatest everything so that we look great for clients. Why are we broke? And then they sell all these chairs, and so you can get this $4,000 chair for like $120. Well, it's more like $200 or $300, but still, $200 or $300 tier of secondhand chair, very awesome. That's what I would suggest. Yeah, and office places hate to pay out ergonomics lawsuits, so they supply nice equipment. Need to listen to the Interstellar soundtrack. Why is there no wave there? Why is there no wave there? Did I just shut this thing off? What's going on? Really, I can only work with triangle on this thing? Oh, is it because I'm touching those pins? No, it's just that this thing is, for some reason, it's fucked. You know, I had this thing almost fully working. The equipment that I'm using to test other equipment has to be reliable. I thought you said we have a lot of ADHD. I also have ADHD, so I don't sit like a normal human being. Isn't that, didn't they, everybody's tried to claim, everyone has tried to claim sitting funny. I had heard it was a bisexual thing. It's an ADHD thing now. Everybody sits weird. Everybody sits weird. All right, it's not an identity. We've got a little, blah, blah, blah. We have a lot of good secondhand office stuff in my area. Lots of oil companies that buy premium stuff and then throw it away when they move office here. That's kind of interesting. Yeah, at the onset of the pandemic and sort of the mid-pandemic time, that was a great time to find office furniture. And that's what I should have done. Amazon had some kind of a giant sale and it was like a birthday. So I'm like, look, I'm gonna get the steel case chair that I've wanted to get. But I could have probably gotten something leather. Although that has its drawbacks in the summertime. With ADHD, it's more of not sitting still. I have the other kind of ADHD. I can sit on a park bench all day and be completely entertained. My desk is a lab bench that I bought from Tektronix for $40. I wish I had that for this equipment. The giant. Oh, Hairbrain, you missed these things. We just did a whole thing about these. You would love this. These are from like the 70s and 80s. The old Tektronix T5006. Actually, wait, you were there at the beginning of it, weren't you? Yeah, we took apart all this stuff and took a look inside of it all. And I've got the A to D module and a test module and stuff like that. I could build some kind of an analysis system with this whole thing. I don't know what to do with them, though. They're so old. I think all of them, like this ARB, the arbitrary waveform generator, could be really useful for what we're doing right now, but kind of not, because I can buy a $27 arbitrary waveform generator off of Amazon that requires just a little bit of soldering to work. It's I kind of don't need the giant rack of equipment. They sound cool when you power them up, though. Sounds like a goddamn jet engine starting. It's like, all right, hold on, my mic's caught on stuff. I gotta come back over here. Apparently all those old COD lobbies were right. I sit kind of gay. I don't know about that, man. They're trying to take that as their identity, but it's just people sit funny. It's the normal thing. It's not in relation to any kind of a thing like that. Apparently all those old, oh no, I'm reading the same comment again and again. All the new Tektronix Scope Desk 7600 starting at $20,000. Yeah, I don't know what to do with all that stuff. I feel like I could hollow it out and use it as a modular synthesizer rack. That would be kind of neat. I don't know what else. Sit on the chair and zoomy. Yeah, cranking them open was a lot of fun. I liked looking at all the design of all the through-hole stuff, because nowadays in test equipment like that, you would find some really advanced design. You would find the things where they're making like capacitors by having two traces that are like circular near one another. So to this day, nobody has built a modular system like the TM5, 500, 5000. It's unfortunate because there are times where it'd be useful. I have a buddy that works at NASA in Maryland, and the test setups that I've seen them putting together there could really use something like the TM5000, because then you would have specific modules that do specific tasks that are coordinated by something that has all the settings in it, and you could change those settings and set up the whole setup to do what you need it to do so that you can run routine tests. That would be I guess a use that they would have for that. But what they have now is just a rack that's full of a bunch of disparate, like different equipment that they poke together. But like in there, you can build a circuit that's going to run something and then have it set. It's weird though, because it's like it lives in a space that we've kind of gotten out of because this thing exists. Because this thing could do all of the work of that TM5000. Some of it could do intrinsically and not be certified measurements, but some of it could just, like, you could make this communicate the GPIB to everybody and set that up. I mean, it's weird. It's kind of, we're in a weird space. Like the A to D module, this thing has 4 A to Ds. Like, I don't know. That's why I'm thinking of just removing all the stuff and then putting modular rack rails on the top and the bottom of it. All right, so I guess we can reliably take this sawtooth wave. We're going to inject the sawtooth wave into the 303 to see if the VCO might be the problem. So we put that into voltage controlled amplifier in. We're still not getting anything on the output. Crank the volume all the way up. So let's do we don't need the oscillator mod. We don't need the filter mod. Change that over to sawtooth. Doesn't matter. We should be seeing our, I think it's reverse sawtooth, or maybe that's a normal sawtooth. Yeah, what would I do with that? All right, gate and amplifier control. And we've got a square wave going in, so it'd be active and inactive on sort of a high frequency, but we should still be able to see our waveform coming out. What if we put it into the filter? This is discouraging. So I thought that this would happen, and I kind of predicted that we would replace the part that I thought was at fault, and then nothing would happen. And that's kind of what I'm seeing here. Although typically I would see some kind of activity. We do, in fact, have output from the voltage-controlled oscillator, and that almost looks like the right thing. It's just not at the right amplitude. It's at a very low frequency, but I guess that can be adjusted too. Oh my God, how could I miss that one? It's right in front of my face. I'm looking at the oscope output, and this thing, the Jojo de Yolo, subbing for 19 months already. Holy crap. Jojo de Yolo, thank you so much. And of course, the Chester Prime for 51 months. I forgot to read the amount of months. That Your Fan was an hour ago, and that was also a tier 1. That Your Fan, thank you so much. That Your Fan is a first badge. But yeah, Chester Willard with a Prime for 51, and then Jojo de Yolo with a tier 1 for 3 months. Thank you so, well, a total of 19. Let's not just get caught up on the streak. Thank you so much. I really appreciate you guys. As some of the people who may or may not be able to watch me during the week, checking out the weekend stream. It's good to do these every now and then. And actually, we've got a good number of viewers. I'm glad you guys are here. Glad you guys are all here. I hope you're enjoying sort of our less focused stream. I'm getting very distracted, but I'm having fun talking to you guys. I'm trying to repair this M303. Something else is wrong, and I think I'm going to have to continue reverse engineering it, though, because currently I'm not getting anything to happen with it. I can bring in the crimes and ornamentation module, which is how we got this thing to work originally. We hit it with a pulse from crimes and ornamentation, and then, but the thing is, like, I'm giving it full amplitude waveforms here. They're full amplitude waveforms, but they are at a higher frequency. They're at a C notes frequency. And the two channels here, let me turn off the useless channels. We're not using these currently, so we can move these channels up into a more of a focused area. And then channel 2, we'll bring it into the middle. And I guess I'll lower this one to here. And we'll take channel 1 and we'll raise it up a little bit. I accidentally turned off channel 2. All right, channel 1, channel 2. Channel 1, channel 2. I got my channel 1, I got my channel 2. Bzz, bzz, bzz. Just joining while I'm trying to fix a Sennheiser EW100G2 wireless receiver. That thing sounds cool. I don't know nothing about nothing. I know nothing about it, but it sounds cool. So there's our sawtooth and our square wave. And it's at a very low frequency indeed, and very low amplitude. So my scope will tell us. I've got the little measurements set up on the right. We've got 2 volts for the maximum, which means about a 4 volt peak to peak. If that's centered, it looks like it's centered moderately. The frequency is 34 hertz, 34-ish, which is about C note. Okay, so that's coming. Oh no, wait, no, 34 hertz. That's a different note. That's not, because we're 260 on this one, which is about C note. That's a different note over here. But 34, whatever. It's still audio frequencies. But man, there's just nothing behind it. There's nothing behind it. So my thought was I could inject one of our waves in here and get something on the output, but I ain't seeing anything. Envelope out. What are you doing? What the hell? What voltage is that? Channel 1. Why is this so... I have it on fine mode. Why is it on fine mode? It needs to be on coarse. How do I turn it to coarse? Oh, there we go. Fine off. Okay, so there's centered on 0. There's 10 volts. In our envelope output, we are just getting a trigger out, aren't we? I have the decay set really high. Yeah, see, there's our frequency coming back in as I set the decay low. So I mean, we know that we're triggering the envelope. That's what we can surmise from this envelope output. Nothing. Accent doesn't do anything here. And then resonance is on the filter. That's not me. So envelope mod and decay are my two controls for this. I can either gate or I can do voltage controlled amplification. It doesn't really matter. The frequency is so high that it's just always triggered. What we would see if I sent it like an occasional pulse is we would see it slowly go back down to 0. And so that can inform the envelope to allow output, or you can have a voltage controlled amplifier through it so it'll fade out the note that you're playing out of your oscillator. Now this would be connected directly to the triangle wave or whatever wave, the square wave that we're observing here. They've got that little, what do you call it? Pompadour on top of the square wave, and that is typical of the 303. So the waveform looks right, it just has no amplitude behind it whatsoever. This should be plus minus about 8 volts. How do I fix this? But when I plug in an external signal that is full amplitude, that disconnects this waveform. So really, we should be seeing my sawtooth, or whatever it is. Yeah, this would be a sawtooth. Hey, what's up, Bothan? How you doing? We should be seeing it on the output here. We see nothing. I got the volume all the way up. Volume all the way up, accent in the middle. We know that even with the decay in either setting, it is permanently triggered, so it should just be on. And I don't think it's going through the cutoff filter. No, it's not. What the heck? Yeah, nothing happening on the output. How much of this thing is possibly broken? Our voltage controlled oscillator is not at the right amplitude, but I thought I could bypass it by putting it directly into the filter. If I put it into VCA mode and I plug in VCA in, nope. Well, voltage controlled filter, voltage controlled amplifier. So that would be amplifier in. The gate is over here. And then that controls accent, which we don't really, we need to see an output in order to have that do anything. So something else is very broken in this. I think starting with our voltage controlled oscillator output. Oh, but the oscillator circuit is so complicated. I've got some of this circuit worked out. I would have to really dive deep into this thing in order to get any other stuff out of this. So we're right back where we started. I've replaced the voltage controlled amplifier chip. I don't. Filter in, amplifier in, gate in should be doing stuff. There should be an output. We've got a little further than this with the. Let me bring the other one over. Let's try the other one. Let's try the other one and see if it's doing the same stuff. I feel like I've taken a step back with this 303. Like as if something is just not connecting properly. We're getting a waveform, so we are putting good power into it. What up, 3D Printer Shack? How you doing? we're in sort of we're deep in troubleshooting this thing, and it's not really cooperating all that much. So I'm going to get, where'd they go? Oh, I didn't even have to get up. Well, it's good to get up and stretch your legs. All right, so this is the other user's M303. Looks very similar, but it is a different unit. And then we got to check this insidious fucking connector to make sure that it's plugged in right. That should be correct. And then over here, got that plugged in correct. That is the chip that I took out of this. And I'm keeping it with it by just taping it to the back. We have not replaced that particular amplifier on this one, but I wanna see what state this one is in. We're just kind of hanging it on the screws. You get in there. Get in there. Get back there. You get out of my way. All right, there we go. Looking for something to print in PLA carbon fiber. I don't think I shared the STL, but you could print out the scan of my middle finger thing. I have an STL for this. You can bump it up to 500% and then bike frame. You trying to kill him? You're trying to kill him. Powered on. Less than 100 milliamps of 12 volts. Nothing is shorted out. This thing should be functioning. Let's check the VCO out. This one is even more restricted and lower frequency. Bring the tune up a little bit. Yeah, all right. So we got the tune going. Our waveform appears to be settling in a weird way. And we've got a maximum of 4 volts and a frequency of 22, which is very low. Our output, probably going to be nothing. There's a little bit of movement there. So if I give it, here, let me move output to the yellow channel. If I give it a gate, that should pretty much permanently gate. And so there is some type of waveform on the output here. Volume works. Scope updating is a little slow. I don't know what's going on with that. Accent, yeah, it's definitely doing stuff. Envelope. All right, it doesn't look right though. The decay. Now, our peak to peak on this one is 5 volts. It should be closer to 10, 8 or something. Hear about the new Bricklayer's slicer algorithm that's supposed to make stronger parts? It's where it staggers the rows. Yeah, I've heard some stuff about it. A little bit of resonance. Frequency cutoff, just kind of mangled the, oh, that was from resonance, I guess. I don't really know if it should be looking like that, because that's supposed to be a square wave. That's a triangle. Something's a little weird here. Mod down. ECF mod doesn't matter. So what if I gave it a different wave in the voltage controlled filter input? There's all of our amplitude. Although we had a much higher frequency signal. This is just a square wave, isn't it? Unreliable sine wave, go. There's the unreliable sine wave. Whoa! Bet you that sounds funky. So that's a frequency cutoff. So if I modify the frequency cutoff, oh no, I think our signal failed. This one is kind of a little faily. I thought that was a triangle wave though. Did I mix up my triangle and my square? What is that's the wave coming in or going out. It goes into the voltage controlled filter and it somehow becomes that. Oh, you know what it is? Because we're using a square wave to do the amplifier cutoff. And it's the same frequency, so it kind of masks itself into a square wave. That's with resonance. Not the resonance. Give it a lot of decay. Now, turn it into an amplifier. Nope. An accent control is doing amplitude for some reason. I need a more reliable way to test these things, don't I? That's volume, so that should always be at full. Plus minus 5 volts, I mean, that's a little bit better than, well, it's better than the one that doesn't do anything, for sure. Yeah, that wave is not being involved. We're injecting our own wave into this. If I did voltage controlled amplifier in, same deal. But now it's after the filter. So we've injected it further down the line of the stuff that the 303 has. So it's the oscillator, the filter, amplifier, and then output and accent. Accent's a weird control. I don't know what exactly that's doing. But if we give it a full amplitude wave, which is what we are giving it, we're giving it something that's similar to, it's at the same amplitude as that wave, which is much louder. So even this one is still struggling to output at the appropriate amplitudes. What in the world caused that to happen? So if we look at the circuit itself, let me turn this off. Look at the circuit itself. There are particular areas of functionality. That's not what I want. That's not what I wanted either. I should put a bolo out on Leb TV Live for my Node Red woes, because I got that on my mind too right now. So there's a couple different like functional blocks in this design. I mean, the stuff is spread out pretty well, but you can see here that I've replaced everything on this board. The origin of the waveform is somewhere in this area, and you can see that there are 2 adjustments on it as well. That's a slope and a range adjustment that allows you to key in on the 1 volt per octave spectrum. It allows you to adjust your analog circuit to be as accurate as possible in that 1 volt per octave. So over here, you have LM3046, I forget which one that is. You have one of these super matched transistor sets where you have 5 transistors that are all super matched to one another. And that allows you to, I guess, fight them against one another in order to create oscillations. I don't know what some of this stuff is doing, but this stuff will then feed back over to the initial VCO output, which I think is coming out of this op amp, which is why I wanted to make sure that that part was replaced. We're still not seeing the amplitude that I think we need, and I've already replaced this stuff, you know, several times on these devices, and they're still messing up. I don't know what the deal is. Let's see. There's some of the function over here is to change the way the the amplifiers work. There's a CD40 or no. One of these parts, I forget which one it is. Not the 4106. One of them resembles very closely a device that I'm actually going to be using in the module tester module, which is just a switch. It's basically a digitally selectable switch module. So you send it a TTL 5 volts, and then it switches an isolated channel line thing. But what that's doing in this circuit is it's connecting these capacitors to the feedback of one of the amplifiers. That's as far as I know. I've been looking into the circuit and I've been trying to get to know how it works. But over here, we have the diode ladder filter. What this does is this uses a particular property of a diode when it's in sort of low voltage conditions. As you bias it with voltage, it will allow more frequencies through. That's just one of the properties of the PN silicon junction diode. What they have here are dual matched transistors. The reason for that is that transistors are a little bit more tightly controlled than diodes. So you don't have to fish for 500 diodes to get 6 that match. Instead, you buy them with pairs, and these will be relatively close to the same specifications. You have a bunch of extra silicon in here, right? Because it's not just a PN junction for a transistor, it's a PNP or an NPN. So you only use one of those junctions. You only use 2 of the pins, and that'll only use 2/3 of your silicon, but it's matched with the stuff on the other side. So you can make your ladder filter out of that. I call it a penis ladder filter because it does look like a penis when you put the circuit down on paper. But yeah, so that's the ladder filter. We know that part works actually. We can't really display it working with the oscilloscope because we don't have a frequency sweep. If we had a whole bunch of different frequencies coming out, we could display it. It's much easier to just hear the effect that it has on like a music coming in and out of it. But that filter leads directly into this LM30700. And we didn't know the identity of any of these parts, by the way. A lot of these were sanded off. But the LM30700 is a transconductance amplifier. These are parts that are designed to basically amplify or dampen a waveform depending on the voltage that you send into them. Transconductance is weird because you're going into amps instead of volts. So instead of your waveform existing in a way that we can display on the oscilloscope, the waveform is the amount of current flowing in that line. It's very strange stuff. Out of the transconductance amplifier, we go to an op amp, and the op amp is set up with just a capacitor on it. What that does is that translates the amplitude back into a voltage signal. And so that voltage signal is then sent to the front panel. No, wait, those are the power supplies. Yeah, that's power going over there. It's sent somewhere else, and I still need to trace all that stuff out, but it basically probably goes back all the way to this header here, or its buddy up here, where it goes to the front panel. So I've got all that mapped out. I know where all that stuff connects. Here's a power supply. This is making a weird voltage. It's like 5.2 or something like that, that then feeds into some of the other circuit elements, some of the other TTL voltage things that are running the show here. So, you know, most of it we know, but the key parts of it, the things that are outputting, the things that are creating the waveform, are a little bit more unknown. I do not know why I'm not getting the amplitude out of this stuff. What's up, Blonde Dog? How you doing? I thought it was this. I thought it was going to be this op amp right here, but it's not. So something else is not functioning, and it's hard for me to really put it down. I mean, we can take a look at what the circuit board looks like if I open up GIMP, for lack of a better program. Whoa, why is this searching weird stuff? GIMP. Boop, 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 boop. So this is like what I used to do as a career, reverse engineering things. We would get a device that might just be pictures. It might be a physical device that you hold in your hands. We got to document it, take pictures of it, and then write a big technical report about exactly how it works and what it's doing. And so there were times when you would have some crazy logic stuff, or some crazy analog stuff, or some crazy RF stuff that you had to learn at a breakneck pace while also providing a schematic and a technical explanation of exactly how the circuit functions. So this is right up my alley, and I should be doing better at this. But I'm not. I'm just not. I don't know why. This thing has really been weird. And I don't think it's the thing where if you replace a couple of the components, it'll break the other components that you didn't replace. I don't think it's that. I don't think that's what's going on here. Where's Open Recent? Hold on. Open. We don't have an Open Recent? Wait a minute. I know this stuff is weird, but Open. Oh, there it is, right. Huh. We don't have an Open Recent because I haven't opened the program in Recent. I think there was one on the desktop, though. Oh my God. Let's just do Oh man, it's in here somewhere, but okay, maybe we'll find it this way. Toot Untitled. No, 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 no. I think there's an M303 folder though. Yeah, here it is. Oh no, this isn't the right one. This is the GIF that we got that tells us exactly what to replace and the identities of some of these chips. So you replace these four, N24, R166, N30, you just can barely see them circled, but it's those parts you would replace. I really wish we got some kind of documentation of what the rest of these things are, but we only know for a fact that these are, you know, CA38, 3086, a 40106, and yeah, Darlington. BC847B, Darlington. Maybe the Darlington is not the right. Has to be a BC847. Maybe I got something that's off spec for that part. That would be this over here. Where is that? Or no, it's a Darlington array. I don't know. I don't know. Hold on, let me open the right thing. So the part... Oh, that's not the right one either. What's that one? Oh, that's just my mixer ideas. What the heck? Somewhere around here, I'm going to have the 303 document. I get, you know, maybe we worked on it so long ago that I still had full access to the server, because I've been saving stuff onto the desktop for a little while because I haven't had the ability to save from this computer to the server. Or it somehow ended up in one of these other... That would be very annoying if it did. Wait, where are we? We're in... Oh, desktop. Yeah, okay, there's nothing else in there. Desktop. Nothing in there. Nothing in there. Wouldn't be in the mutable environment. No. I'm seeing if it got it somewhere that it wasn't supposed to be. Nah, none of this stuff. 4048, capture, diode ladder. That's a different thing. That's actually the diode ladder circuit that we were talking about. This would be an XCF, M303 schematic trace.xcf. It was on the desktop. So this is the document. I took a very detailed picture, or a series of detailed pictures, using my microscope in order to highlight all of the traces on the board on the top and the bottom layer. And this is sort of in the working document that I have been planning all of the, basically putting together the whole schematic with. And then I've got like a, whatever it's connected to on the front panel in a different color, all on different layers so that I can turn stuff on and off as I need to. See, like the identity of all the ICs, I can turn on and off, etc., etc. So we were looking over here, and you can see that this is the voltage-controlled switches. So we're actually adding these two capacitors on the line when we control those. We've got a bunch of transistors facing one another. These are sort of, is that fuzzy logic? What is that again? Sort of an inverter that puts a little Schmidt triggering logic into it. Our frequency and slope adjustments are over here. I haven't really figured those out fully yet. There's still a little bit of question marks around that. But then we have our super matched transistor chip. This is kind of, the M303 uses a very old part. It's a part that is in a can. It's in like a metal can, and it is a pair of super matched transistors. Well, we're not using those as much anymore for our oscillations and waveforms. We have crystals, we have digital electronics, we have all kinds of other ways to make these frequencies, and the frequencies that they were making is so low that it's just not all that useful, right? So they stopped kind of making them, and instead they started making these, which were a set of 5 super matched transistors inside of a little chip. This is now obsolete, and it's getting harder to find. I don't know what we do going forward from there, because I don't know if they are doing as much to supermatch transistors anymore. But the 3046, you can still find them, but they are starting to get a little bit more rare. And I tried to get this thing into, and there's our quad op amp, into some kind of a usable schematic. That's that that op amp over there, and then the transconductance amplifier is this thing. That's what those little cycles are in the front of this, or what, the diodes, I guess. I don't know. Transconductance amplifier. It's amplifying a current. Actually, maybe the Darlingtons here are what's moving it into the voltage spectrum. Either way, it goes over to this dual op amp, and then from there, I guess back into the amplifier. I don't know where the amplifier is going from there. I haven't mapped it all out. But I've got all the tools I need to do it. We can open up Fusion where I've got the schematic, and I can take a look at that a little bit. But is Fusion open on the other computer? It's not. Let's open up Fusion and take a look. Autodesk Fusion. Wow, why did that not have the logo with it? It would look like just a generic application. That was very strange. Very strange things going on at the start menu. Yeah, I'm at an impasse with this circuit. I don't know what to do next. I had a little bit of a plan, and I was hoping that it would mostly get it to work again, but one of them seems like a lot of the stuff's broken, and the other one seems like, I don't even know, man. It just seems like something, I'm not getting something. Like there's a piece of it that I'm not getting. It's not outputting a waveform at the right amplitude, but every time I replace all those parts, I get the same exact results of having a very low amplitude waveform coming out of the thing. So what is the signal path here that I'm not getting? Expires in 22 days. Oh my God. What is it doing? It's presumably opening stuff. There we go. So back to the modular stuff. Why did it choose RC car project? It's so weird. Oh, there's an update or something. What's going on? Unlock more. No, go away. New version of Fusion has landed. Let's leave that alone. Hey, Nano, how's it going? Okay, so we're going to modular synthesizer projects, and we're looking at the M303, and I'm looking at my reverse engineering. Hey folks, my setup, I use Behringer TD3 and a MAM MB33 for acidizing. Neat. Now here's all the work that I've gotten done. No, just kidding. Wait a second. Oh God, there's nothing here. Wait a minute. Wait a minute. Whoa. I thought there was more circuit to it than that. Okay, it must be in a different document. I think it's in an MS Paint document then, where I have all of the circuit work that I've done so far. I guess I haven't moved it over to CAD yet. There's nothing here, unless it's on a separate page. Hold on, let's see. Beats. Oh, there it is. Okay, phew. I thought all this work went away. So there are still areas of the circuit that I just don't know what's going on. It is harrowing. There's stuff here that's just floating that I haven't worked out yet. I've done a lot of work to kind of get the various areas together, not to mention organizing it at all. It just branches of paths going on here. In the end, this schematic is going to be daunting and confusing for sure. But I'm trying to get a sense of what's connected to what. It's become more branchy and confusing than I could handle. In the end, I'll have a working document where I can build an M303. But so far, I've got 2 dead M303s. I don't know what the hell is going on. I did a lot of the diode ladder filter mapping, figuring out what connects to where. The output here at the very top is going to the transconductance amplifier. I don't know if I have that in yet. There's the TL072D. Yeah, that's weird. So with the mixer circuit, we've got a different sort of different sort of output circuit. If I still got that open, I think that's over here. This is what's turning it into, so over here it's in the transconductance amplifier. So it is a current level that describes the waveform, and then we turn it into a voltage level that describes the waveform. So that's what this little feedback Jiminy Jam is doing. And I expected to see something like this in sort of the main circuit, but for some reason this is what's in the main circuit. Although this is the entrance way. So this, I think this is the, yeah, VCA in. So voltage controlled amplifier in doesn't, it's not audio, it's a control signal. Buffered, put around 0, for some reason parallel resistors, and then it's put into the, this would be resonance control over here. It's the current that runs down through here that's part of the control, and I didn't finish this. Oh man, this is like this is the really boring stuff that I didn't want to do today. I was hoping that we'd do a little bit more soldering. I guess we can try to replace the one part on the slightly more working circuit and see if that does anything. But as far as I know, we need to be over here where it's creating the waveform. And I don't know a ton about what it's doing in order to create the waveform. There's some parts of the circuit that I just truly do not understand. Somewhere around here is where it's creating that oscillation. But for some reason, the oscillation just isn't as heavy as it needs to be. So not as much amplitude as I need out of it. Which is weird, right? What am I looking for? I'm looking for this. Because, yeah, we're making the signal over here. Let's see, those are ins and outs. Our final output is coming from where? Cutoff, VCA, gate, CV in, tune, select. VCO out is coming directly from that oscillator. So these pins over here are doing the VCO output. So any of the stuff that's associated with those, I would point to as being the cause of our VCO not being all that bright. So what about, where's it coming from? That's the question right now, is where is it coming from? So the filter in, that goes directly through the front panel. The cutoff, the headphone jacks that make up these modular synthesizers sometimes have a switch in them, so that when you plug a cable in, you can cut off part of the signal. And usually that would be through grounding it, I guess. But in this case, the cutoff is being used so that if you plug in an external signal in the VCF in pin, it cuts off the VCO. So both the VCO and the VCF in are being fed from these lines here. VCO out does not cut off, but VCF in does. So if you plug something in here, the VCO is cut off, the VCO out still functions. So they're on either side of this 100 kilo ohm resistor. So our signal is then coming from over here where it goes through a capacitor. The capacitor is ensuring that our waveform is centered around 0. If we were to send a DC level in there, it would block it. The DC level would offset your signal. So if you have DC and an AC waveform, if you have DC at 3 volts, that AC waveform is now going to be 3 volts plus whatever the AC is doing, which is plus and minus voltages, so that AC waveform would be centered around that DC. They do this in order to use things like 3-volt DC electronics to power something that's making waveforms. You can just add a voltage to that waveform, half of whatever your V input is, and then it would center that waveform on half of that voltage. It's one of those tricks about referential voltages that we use in order to have AC things happen from DC circuits. But so what we're doing here is we are just putting a capacitor in there to be safe and make sure that our waveform is centered around 0, just in case there happens to be an intrinsic DC offset coming from somewhere else. So looking at the way that the traces go, we go back over to the front panel where we hit the selector. That doesn't make any sense. Oh yeah, we're going backwards. So the common pin on this switch is going to our output. Whatever we select here goes to the output. So our triangle wave and our square wave are largely separated from one another at this point. And this switch is determining which one we send through the rest of the chain of the synthesizer. So this is where Carl Cox decides whether it's going to go beep, 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 or brr, 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 right? It just decides how harsh the sounds coming out of that knob is, and then he's going to spend about 11 hours at the club going like this. And everybody loves it. So our two waveforms are coming from here. They both look like they are equally limited in amplitude. Like if I turn this thing on and we go back to looking at our, let's just go back to brass tacks here. I take this one and I plug it into the output, and we get a very limited signal indeed, but it also seems to be offset. Why is it offset? And this is our waveform with a little pompadour on it. We go to our triangle wave. Well, now it's all the way down there. So is our VCO out is after the capacitor. So how's that even possible? VCO out is definitely after the capacitor. If we unplug it, then it sends it to VCF in. This is very strange, very strange. Very, very strange indeed. So these are largely separate, but they are both at about the same amplitude, peak to peak. Our VPP is 4.3 and 3.1. What does it all mean? Even though they're a little bit weird on the offset voltages there. Where would it be even picking up an offset voltage? I mean, this is after a huge capacitor. The huge capacitor should be making sure that these things are sound, of sound body and mind, or no, are made up of waveforms and therefore sound. I don't know, man. Yeah, welcome to a weekend stream. We're kind of trying to figure out these M303s here. Maybe we can make a little bit of progress if I sort of use you guys as a rubber duck in this case. Both of our devices are doing the same thing, and I've replaced similar parts on both of them. But let's keep tracing this out. So both of our waveforms are coming back in this direction, right? We hit a bunch of resistors here. So I have a 105. Well, it looks like 105.1. I don't know if that's 105.1, but that's I don't know. We got a series of resistors acting as I suppose some of them are a filter. Yeah, this is all annoying stuff. Okay, so this transistor is taking our triangle waveform and it is turning it into a trigger on and off. So that turns it into that square. I don't know what's creating the pompadour, but maybe the big capacitor over there is helping with the pompadour. Because our waveform is flat and then it comes up and overshoots and then falls back down kind of lazily, and then it's cut again. So in triggering that PNP with a triangle wave, I probably should find a new way to represent the triangle wave than doing this. Get a little too exuberant on that and send the wrong signal. God, I hate that man. All right, anyway, so coming from a theoretical PNP, I put a P on top of it because I think it's PNP. It is triggered by this little capacitor circuit here that is being fed a triangle wave somewhere along the line. The similarities between our triangle and our square waveform originate somewhere in their common creation. So they are commonly created by the electronics that we're just getting into now. So what's that? What's this one here? This one here is coming up and that's going into tune. We don't have to worry about that right now. So we've got the resistors, one of them going to ground in sort of like an H-bridgey kind of thing. These are being catered to triggering the transistor. And that capacitor is probably the reason why we've got a pompadour on top of our square wave. And that signal's coming from over here. Is that just a pull-up? Wait, if that's a pull-up, wait a minute. What? No. What in the honky-tonk is going on here? Wait a second. power input goes to these two. I don't know which power. Which one is that? Oh, no, wait a second. It's not power. So output from a unity gain op amp, which is being fed from question marks here, fed from down here. Okay, so unity gain op amp coming out here. There's a test point, and that goes into these two resistors here, branches out to the output, and also goes to the square wave. There is another op amp whose positive input is coming from that triangle wave. Triangle wave through a 1002, so that's going to be 100 with 2 zeros behind it, right? Which makes it 10K. Am I right about that? 0, 0. Yeah, 10K. 10 kilo ohm resistors, so it's a pretty big resistor. Not a lot's getting through. 10 kilo ohm resistor. There's two 10 kilo ohm resistors here. This one goes to ground. So from minus to ground, minus should also have something else coming. No, plus it's a non-inverting circuit. It worked okay. Yeah, it's doing okay. It's the wonkiness of this tester is not really helping me, and I don't have anything set up to be a gate. So I kind of need to work on my module testing module a bit more. I think that'll net me some slightly better results, because then I can actually like trigger stuff. But right now we're running into the same problem that we ran into originally on this thing, which is that the output from the oscillator is way weaker than I thought it would be. And my thought was, if I replace this op amp right here, we would somehow have full amplitude signals. We don't. I replaced it, and we're in the same boat that we were before, where things just aren't quite doing what they should do. I don't have any repair documents on this thing, so I don't know where my waveform should be. I only know theoretical limitations. So I'm walking through the circuit right now. You know, I didn't really explain that to you guys. I'm backed into a corner right now. I don't know what to do. I need to keep my stream punchy, and I need to continue to do stuff. And I need to move forward with projects, and I got to do it all gracefully and while communicating with you guys exactly what's going on. And I need to keep you guys with me and just make it simple. So we are troubleshooting. Troubleshooting is eliminating a bunch of factors of things that might be wrong with something. We've had a lot of experience with these modules before. I have 2 of them. They're exhibiting about the same thing that I don't know exactly what's going on. I don't know where it's coming from. So I'm trying to walk backwards from our bad result and figure out what house of cards is tumbled. So as I'm going backwards through the circuit, we're starting at the output and we're going piece by piece, studying where this stuff comes from. And I can look at the circuit, and I know this circuit well. I've studied the circuit for some time. I don't have a good schematic document. What we do have, though, is we have the original working schematic document of the TB303. It's a little different, though. Works a little differently. Some of the voltages are different because the M303 worked into some of these functional areas control voltages. And control voltages are plus minus 10 volt signals on a modular synthesizer that exhibit control over something. So instead of you sitting there with the knob in your fingers going like this, like you were Carl Cox in the 90s, instead you have a low frequency oscillator coming into the circuit and moving up and down in such a manner as to mimic my movement of a control voltage knob. So, or control knob. You can time all kinds of stuff with your music. You can put in all kinds of like splitters and combiners and just do all kinds of wacky nonsense in order to make sure that your modular synthesizer is doing the job of like 30 people messing with analog synthesizers. Really cool stuff. A lot of fun, but we are trying to walk back from our weak output and figure out where that's coming from. Why is it so weak? There is not a volume knob on this, right? So something is either broken. I don't think something's out of adjustment, but again, I don't have like a working M303 to compare this all to. Guten Abend. Guten Abend. I don't know. Allerseits. Allerseits? Guten Abend, allerseits? No, I'm pronouncing it totally. I should have taken German in high school. I regret that. I regret that largely. I took Latin, which could help me learn German, I guess. But I should have really, taking German would have been a really good idea, because the amount of European interactions I have with people who know German is oddly high. Although I could have also taken Chinese, and that would have helped me out a lot more too. Latin, yeah, whatever. It didn't really help me that much. Universal language, my ass. Pretty good pronunciation for a non-German. There's some stuff I know how to say, but you got the stuff that I don't. It's one of the things about me is that I sing. I used to sing in choir a lot. And so Dat Dietz. Hey, Dat Dietz with 72 months of excellence. Thank you. Appreciate the compliment. Thank you. Now, one of the things I used to sing. So that exposed me to quite a lot of Latin, some other languages along the line, and it introduced me in how to learn to sing things just by phonetics. And so, just about the time going to college, Dollar Mendy became popular, and I learned how to get that just right without knowing any of it. And I met a bunch of Indian people in college, and they were shocked that I was able to pronounce it so true to form. And I'm like, dude, I'm just repeating what I heard. It's sort of the same thing that I tried to do with the Leak Spin song, the Scandinavian, is it Finnish? I don't know if it's, I forget what, but it's gobbledygook, right? They're just kind of riffing, but every now and then that pops into my head. And the guy on the bongos redid it, and all the conservatives took it as their meme or something. I don't know what the fuck happened. The internet's weird. Anyway, we're walking backwards. We're walking backwards from where I know the voltage-controlled oscillator output. So this pin right here that I've highlighted in white, this pin is representing a physical pin on the board, goes to the output connector, and that's where we're plugging in our oscilloscope. So I can trace from there. Oh God, there's no way. I forget how to pronounce the B, the weird B. Ich, il, I don't, what was the, damn it, I forgot it. Is the apology. What was that? All the guys banging on the table or doing the my brain's broken, I'm sorry. Bitte, there we go. Bitte. I don't know what the fuck I'm saying. Sort of a ZG. Those two letters were not meant to go anywhere near each other, and you're trying to kill me. That's assault. That's actually attacking me by putting those two letters next to each other. I can't do that. I'm gonna choke. That is a physical attack. So VCO out is coming from that pin. We know that. That's what we're looking at on the oscilloscope, right? When we see this pathetic waveform that doesn't describe this thing functioning at all. This thing is the waveform output that we're getting from this thing, and the peak-to-peak value is 3.1 volts. We can flip over to our triangle, which is our OG wave. It really shouldn't be offset like this, although in the TB303 manual, it does describe this as being offset like that. And I think it's of this amplitude. I'm not sure. Either way, whatever we're getting on the output of this thing is non-existent. It does not have the amplitude. It should be plus minus 10 volts almost. Because it's an audio waveform on a modular synthesizer. So something is still broken. I have the volume all the way up. Something is still broken. This VCO output, I'm not sure if it should be this small. This could be functioning perfectly fine, and I'm just not aware. But something isn't boosting it up. The complete dialects are just not understandable. The accents are more or less understandable. Oh, man, I got no idea, man. I'm sitting here. I'm an American. I barely know what my own town's layout is, let alone what other countries are talking. Look, guys, I got more to worry about with airplanes fucking falling out of the sky in Philadelphia than... I'm in a basement right now for very good reason. It's getting dangerous out there. Have you seen the state of things? Holy shit. So our VCO out is coming out of this trace right here. So we follow this trace all the way over and we go, by God, there is a 10K, 100K resistor on this thing. The 100K resistor is there as a current limiting resistor. That just makes sure that whatever piece of the circuit that this is going to be connected to next isn't slurping it down too hard. It also, I get, does it isolate from the VCO? Maybe. Either way, this is the part where it connects to the rest of the circuit. If I plug something into the VCF in, it will cut off that waveform, and we can only access it through the VCO output. That's the stuff that Acid Labs brought to the table there by redesigning this for modular synthesizers. So that 100K, we know that has nothing to do with everything being quiet, although it does contribute to it. But Saturday evening entertainment. Man, I don't know how. I could not watch myself on Saturday evening. Although I can't watch myself at all either. Oh no, I'm gonna die. Wow, that was a cough. Oh, there goes my voice. Okay, I'm back. All right, yeah, so we follow this trace down, and oh look, there is an electrolytic capacitor in the way. What is an electrolytic capacitor doing in this circuit? When you have a waveform and you want any sort of DC influence on that waveform to be gone, you put it through a capacitor. And the reason behind that, if I can just indulge myself with a little bit of MS Paint, the reason that capacitor blocks the DC waveform while allowing the AC waveform is because an AC waveform looks like this, right? Whereas a DC waveform tries to get in and it hits off of the side of the capacitor like that. That's not actually why that happens, but either way, you can actually think of it that way, because any DC element associated with waveform is going to be killed by that capacitor. It's going to be removed, and so your waveform is actually centered. What I mean by centered is whatever reference point you have to 0 on that waveform. So half of the waveform is going to go above, half of the waveform is going to go below. That's just the way it works. It's not like this thing is sensing the 0 point. It just knows where the peaks are, and the physics of the capacitor will take it into that range. So your capacitor is blocking any DC element that might be present in your circuit ahead of this. From there, this circuit jumps back to the front panel. So before it goes through the capacitor, it's going back over here to the front panel. It's like a thermos. You know, the thermos knows to keep hot things hot and cold things cold. Anyway, so over here, this is a grossly inadequate explanation, but you guys aren't going to get anything better. We have our square wave or triangle wave selector. So the piece right before we get our output is this switch on the front selecting whether or not it's a triangle or a square. So then we have these triangle wave and the square wave being generated in this immediate vicinity. If we follow the square wave, it comes down here and skips under our capacitor, and it goes to a PNP. So if I simply go to the internet now, and I take a Hail Mary, and I do a, hold on, where's my, okay. So if I do PNP square wave circuit, and AI is going to be like, hey, can I interject? And I'm like, no, shut the fuck up. Images. So we can look up circuit structures and find things that generate square waves with a PNP transistor. If you trigger the transistor and you have your power in going to it, you can just make a square wave that way. You can just have it go from power to ground, power to ground, power to ground. In the case of ours, I guess it's plus and minus. What can I do? Square wave circuit from sawtooth. So we get some circuits here that we could potentially take a look at. This one seems kind of close. Don't. Okay. Two different circuits that this person was looking at in order to make a square wave from a triangle wave. So we've got a resistor biasing the base of the transistor, and I guess our input were sort of triggering. Well, that's a little weird. Yeah, but anyway, so you know, stuff like that. We can look up circuits that are sort of similar. And we can see a little bit of that circuit in here. I mean, we've got our big capacitor sitting nearby. We've got our transistor that's connected to ground. And then we have our sawtooth coming in through some kind of a shaping thing on the base. So that's sort of more or less what we're looking at. And I'm not looking to get an exact description of what's going on here, because we're tracing elements that are going to inform us what might be broken in the circuit. Now, because our triangle wave and our square wave are similarly low amplitude, I'm inclined to think that that transistor is not at fault here. I think it might be some other element of this is at fault. So we move further back. We move further back on the circuit. And as we do, our triangle and our square wave are actually branching off of this signal right here. This signal right here is not coming from this op amp. It's not coming from this op amp. It goes to this op amp, but it's not coming from this op amp. What is this op amp even doing? That one is going back to this transistor, but that one is connected to power. It goes back over here. That's a power line. Yeah, that's positive voltage. Go back. Oh, I see. This is positive to the op amp. But the op amp output goes to this resistor. And then this is a pull-up. So it's triggering this, which is what? Triggering it, but it's got a little sustain on the trigger, but this is positive power. So we are triggering this line across the capacitor that goes here and then up to a matched transistor pair. So that's part of the oscillation, I think. But then this is coming directly out of a unity gain amplifier, which points me towards this chip right here. This is one of the chips that we replaced. It's the op amp chip, the TLO74. I mean, this is just, you guys can see how I've been going around in circles on this thing, not getting the results that I've wanted to. I've replaced this part right here, and nothing happened to increase our amplitude. I do not know what's going on. If I test in the back here with this thing running, and I punch into, where's that line? Let's see, we're opposite of those things, and we've got 1, 2, and then a third that's offset a little bit. So that's this one right here. So if I plug my other probe into here, oh, you guys can't see that. So this is coming direct here. Let's center channel 2. All right, so both of these are centered, so they should be similar waveforms. And if I plug in right here, I should see what's coming out of that. Now that is plus 5 volts. That's looking like a legitimate signal. What's coming off of the weird transistor? Oh, interesting. Full 12 volt spiky dude. That's that test point before the capacitor, before the base of the transistor. So this is being induced, and I guess the capacitor is what's discharging. What's relatable? What did I say? What did I say? I don't even know. So, like, that is a full-ass signal. Oh, not finding the problem. Yeah, this has been very frustrating. These M303s have really put me through the ringer on all this stuff. That's just a power signal. I mean, at the test point, that's a pretty righteous sawtooth. Well, I guess we can see why it's cut off a little bit. Because it's oversaturating. I don't know, like every time I give this to Dave, he's like, it's too quiet. I don't know why. I'm like, God fucking damn it. And our VCO out is not giving us like full amplitude. So in the electronics that we have over in that section, maybe it is, well, no, but this is just squarizing it. And the square wave looks exactly like it should. It's got the pompadour, it's in its lane, it's thriving. So what is failing? Nothing is failing. Nothing. Everything's fine. Everything works great. Nothing is failing. Everything is totally fine and great. Fine and great. Nothing to worry about. Everybody's fine. Everybody's perfectly fine. Nothing is wrong. Nothing. Just nothing. I don't get it. I do not. This thing has defeated me. I think maybe this op amp is not associated with this part of the circuit. I think this is just here because the tune and the CV in are over here. CV in goes somewhere else entirely. Tune does come down into this circuit that, where is this feeding though? No, but this is feeding over here. And if we looked at this waveform right here, and that was also a triangle wave. Maybe it's this transistor right here. So that signal right, that middle test point, the one right here. Middle test point. That's not my, there it is. Okay, that's the spiky boy. You guys can't see it. Yeah, and then the one coming off of the op amp is the robust 0 to 10 volt signal. So this is robust 0 to 10 volt. What up, Ryan Labs? How you doing? I'm at my wit's end right now. We replaced the part that I thought I had to replace, which is this op amp right here. It didn't do anything. So I'm like, I don't want to waste everybody's time. So we're thinking very closely about what this circuit is doing. We're trying to sort of hopefully illuminate some kind of a failure in the circuit by kind of going over all the different functionality. Rex sucks at stuff. That's a righteous Twitch name. How you doing? So we've got our tune knob. The tune knob goes under the board and out and over to this amp. No, it actually still goes out, way out, over to this resistor here, this 103. 100 with 3 zeros off of it. That's a 100 kilo ohm resistor. And it feeds into this piece of the circuit right here, which goes into our two adjustments out here. So this is probably like a typical transistor oscillator. What's this for? It seems cool. M Audio created the M303 so that you could automate Carl Cox inside of your modular synthesizer, right? You can relegate Carl Cox to his regal original form, which is a low frequency oscillator. You can plug that into there and that'll make all your squelpy acid house. I have two of them. I have two of them because they break in a routine manner. The power plug has to be plugged in offset by 2 pins. And it is able to be plugged in anywhere on this thing and there are no markings. So when you plug it in wrong, it blows up a bunch of the circuit. So Rygal USA office is localish to me. Tell them to get me into like their creators program so they can send me some free shit. Bust down their door, walk right up to the secretary or whoever's running the main lobby and go, listen to me. I know this streamer. He's perfectly spherical and his name is Oh Bother. He's as close to the physics problem representation of a cow as you can get with uniform density. And get them to send me cool stuff. Been there, done that. What is a perfectly spherical cow? These had to be repaired in the same way so many times that the creator has created a creation that is a routine repair guide as to the parts that you have to replace when these things blow up. And so I did the repair, and it still didn't really fix these things, and I'm not totally certain why or how or what. And so I've been going through over the past couple months, I haven't been working on this very much, but I've been going through and identifying pieces of the circuit and how they work, right? And so I've been working on putting that all down into like a schematic that I can follow. It turns out it's easier to just follow it on the board directly. There's just a lot of crazy stuff going on the board. I wanted it to be like a schematic, but it's just not. You know, like this is what it ended up looking like, and it's just a whole bunch of circuit structures that I've been putting together and not really understanding what the hell they're even doing. You're a music producer. I haven't gotten to the music production part of my modular synthesizer build. Turns out it's a lot more complicated than I thought. The stuff on the left there is a couple of the modules, and a lot of them don't work. I think my next endeavor is to build a module testing module, and I'm kind of doing it myself with some influence from mutable instrument circuits. Cut off those extra pins from the IDC ribbon header. What are you talking about? No. There's plenty of ways to fix the connector issue. The people who sent me, Joel Deadmau5 should be your friend. He knows a lot. I know a lot about the circuits, not about the music production. But listen. You're like, hey, cool. You know synthesizer stuff. You should know orbital. And it's like these people are far more like I'm just like a bug under their heel. Look. There's 73 people watching me get confused about what is connected to what on a circuit board. I am not at the level where I'm rubbing elbows with the prodigy, right? I'm not calling up Deadmau5 on the phone and being like, hey man, what's up? That ain't happening, man. I am a worm. I have seen the Deadmau5 streams and he does a really cool job, but there are some other musicians. Just call him. No, I can't. Not after the fight we had. So for 10 years of my life, I reverse engineered IEDs. They would send stuff FedEx to the FBI. They would literally FedEx fucking bomb electronics to the FBI. Like, I'm going to send this shit to the FBI, taping up a box. I'm going to send this shit to the FBI. It's like, what the fuck? Anyway, so the Army or whatever, the EOD, they would send these boxes to the FBI. We'd get something in, we'd put on gloves and take photos of it, and we'd figure out exactly how it works, what the circuit structures look like. So this is right up my alley. We'd write huge reports that detail how these circuits work in the bombs. This is an analog circuit though, so it's a little bit new to me. It's not a lot that I know about. I've been working on this for a while. I've gotten very familiar with the circuit, but this kind of stuff is what we used to do at some level. I mean, every now and then we wouldn't have to do things this way, but you know, you put all your parts down and it's this big, giant, confusing mess, and then you kind of work through your circuits and you organize them over and over again until it actually looks nice. So this is a synth module or a patch. This is a module. It's actually kind of the contents of several modules in one. It's basically, what if you had a 303, but you made the 303 to be a modular synthesizer. So you can put your control voltages into the 303 and control the various parts of the 303. So this is a couple different modules: voltage controlled amplifier, voltage controlled filter, an attenuator, and a voltage controlled oscillator, all in one. And it has that signature sound of the M303. It does what an M303 does when you put the brass tacks to the M303. It squelps and squeeches all the same way. Used to play CB tag with the Prime Minister, aka Sir Mix-a-Lot. That's kind of cool. So I was posted on Reddit, right? They asked Sir Mix-a-Lot when he liked to do hobbies, and he said design analog circuits. He was an EE. What the fuck, really? I didn't know that. Sir Mix-a-Lot, that's cool. He's remained relevant and has not had huge scandals around him, hasn't he? That's always nice. Yeah, that's kind of cool. I didn't know that about Sir Mix-a-Lot. Well, my brain ain't good to do this shit. Look, you don't gotta have good brain. I got bad brain too. I don't know. There's a familiarity with the analog stuff that I've sort of found over the years of doing it at this point. I started in on modular synthesizers like a year and a half ago, 2 years ago, probably at this point. What window am I looking for? Where's my GIMP? I lost my GIMP. There it is. There's a familiarity that I've sort of come accustomed to with this stuff. Yeah, I mean, you could just work it with plugins and stuff, but I like this visceral part of it. And the part that really attracted me to modular synthesizers was that you can buy the circuit boards without any parts. You can just buy the circuit board and they go, good luck, asshole. Don't contact the creator. And you're like, oh, okay, how do I build this? Like, I'll just fucking do it, bye. I love that because you just buy them and then you have to do everything yourself. So I've had to source parts, I've had to find the how-tos, find the tuning guides and all that stuff for these circuits. At a certain point, electronics repair is like janitor work. You sweep the board, remove the shit stains, and unclog the traces. Pretty much. I mean, if you get to know a couple circuit structures and they become ubiquitous to the operation of this thing, to the point where it feels like you are looking at, have you guys ever played Factorio? Have you ever played Satisfactory? It's exactly the fucking same. Same part of the brain is being itched, and it's the same stuff. You go, how much is coming out of this thing? How much is going into this thing? Can this thing handle that? That branch is off here. This goes there. I need to connect this without interfering with that. That's it. And you just kind of get to know circuits on that level. I wonder if I could reverse engineer a mini Moog. Well, what I've done here is I've taken photos of the top and the bottom of the board, and I've overlaid them on top of one another. If you get a reverse engineer, you back them into a corner, this is what they will do. This way, I have not had to use most of my brain in order to do this. So I have the bottom of the board, I have the top of the board. One of them is inverted so that all of the holes just about line up. And so all I did was trace out where the traces on the two boards go. Now you could do this with image manipulating and all kinds of stuff like that, but I take a fairly simplistic approach to this, and what works, works. I don't need to use AI, I don't need to use image manipulation and stuff in order to put this together. So from there, I can go through with a highlighter and do basically highlight parts of the board that I've put down into a schematic. And by doing that, I will keep a sort of a log of all the connections that I've made. Once you're done doing that, and that's a lot of work, once you're done connecting all of that, you take a look at your schematic and you go, dear God, what the hell did I just put together? You start organizing that, and you organize that based on functionality. You think, well, okay, this is here, this does this does that. What does a circuit look like that does that thing? Like over here, the penis ladder filter, as I like to call it. This is a diode ladder filter. What this is, where is that? What this is are a bunch of transistors hooked up in a particular way. The thing about transistors is that a transistor is 1.5 diodes smashed together. You get that P junction, you get that N junction, you get that P junction, you have a transistor. But if you only connect the two of the pins, it's a diode. It's essentially a diode. Transistors are built with a little bit more tight control, and so if you replace your diodes in a diode ladder filter with transistors, they are pretty well matched to one another, and you end up with a filter that sounds consistent in stereo when you fade in and out. The diode ladder filter takes advantage of a low voltage property of diodes where they turn into a sort of frequency filter in the current domain. It's a little complicated what it does, but the point is you could just look up circuits for that kind of stuff. Where is that? Oh, it was in Paint, wasn't it? Was it this one? No, it wasn't on any of these. Here, you can just look up diode ladder filter. Diode ladder filter, and you look up, what the common schematic representation is of something like that. You get something like this, and this is typically the form it takes. I call it a penis ladder filter because, I mean, come on. No, circuit simulation is the product of the devil. It is a practical joke that programmers have unleashed on the world against electrical engineers. All right, well, somewhere in there is a link to a pretty good circuit representation of them. I had to do a lot of reading in order to learn how these things worked, and analyzing this site, analyzing the Moog filter was really, really useful. All about circuits. There's a whole set of articles about the ladder filters that I had to read up on. I had to do homework in order to get this properly. This is one method of doing it, but there are other methods of creating that ladder, and they all take advantage of that. Get out of here. They all take advantage of the frequency properties of a low voltage diode, of a diode and low voltage whatever parameters. There's other articles that have the very specific one. Simulations are only as good as the models you use. Most of them are shit. And for the purposes of the stuff that I do, I'm not simulating. I'm not going to put an entire M303 into simulation. That may be very useful, but I wouldn't know where to source good models, and it would be a lot of trouble. It's a lot more trouble than I think it might be worth. Yeah, true in all physics. Yeah, even if you're doing FEA or any of those other simulation things, it's you get out what you put in, and I'm not putting out. Where is the window that I'm looking for? Okay, so we were looking at we were looking at the path of the circuit, and we're trying to figure out why we're not getting a full amplitude waveform out of this thing. So we've taken it back and we've discovered that our square and our triangle waves are originally, our sawtooth and our square wave are originally a sawtooth wave. So the sawtooth wave is very hastily being converted into a square wave, which is likely why we have some kind of a pompadour on top of our square wave. If we go over to the square wave here, you can see it's got a little bit of like a pompadour sticking out the top of the square wave. It's not that accurate of a square. It doesn't need to be, because we're in music. We're not making a waveform in order to do science. Our triangle wave is just about the same amplitude, although for some reason it's offset really badly. Don't know what's doing that. One of the big challenges of this thing originally was that all of the important ICs had been sanded. So all of the part numbers were gone, and we had to use pinouts, common structures, and things like that in order to make sure that we had the right chips so that we could reverse engineer it. We're 99% certain about all the chips that we have now. We're pretty certain we have what we've designated on these documents. So we've got our square wave in this section here. That's basically everything you see on screen. Our triangle wave, sawtooth wave, is being converted into a square wave. We're just using that front edge in order to trigger the square, I guess. And then I guess we're persisting it with a diode, or sorry, with a capacitor. That's probably why it's overshooting and doing some weird stuff. The amplitude is still just about the same as the triangle wave, though. So is that part of the problem? I don't think the square wave generation is part of the problem. I don't know what happens to it when it gets up to full voltage, though. It's possible that nothing in the section is broken and that low amplitude is just part of the output of the device. I don't have a working M303 to test this against. If any of y'all have a working M303, although isn't this in one of the simulators? Like, what are the modular Eurorack simulator M303? I guess we could try YouTube videos to see. No, but they're not looking at it on an oscilloscope. Of course they're German. Okay. How to make a modular TB303? No. Who's that? Who the hell is that? What the fuck? What the hell? What? Hey, wait a minute. What's the overall problem with it? Our output is abysmally low. If I get this thing to output at all, and I'm kind of using a weird gate here, but this'll just permanently hit the gate open. Yeah, like that just opens up the gate. My signal amplitude is like ±5. Actually, well, that is 10 volts TBF. Perhaps I've misjudged you. Even though your waveform is actually utter shit right now. Hold on one sec. No, we don't need all the resonance on that. More cutoff? No, that doesn't do anything. Turn up the frequency. Just get as many waves as I can see. No envelope mod. Super duper decay doesn't matter. Oh, lower the accent. Well, the only thing that's pulling it back into the right voltage range is the accent mod. We can move that a little bit closer together. We can just do that. And then square wave looks like that. Triangle looks like, sawtooth rather looks like that. That ain't right. Something's wrong. Yeah, so what this stuff is doing over here, this is just creating waveforms. So that's what I'm feeding it as a gate signal. That's okay because each one of these is a trigger of the gate, and the decay just makes it a constant trigger. So basically, all this is doing is just turning it on. This just turns it on. Says, hey, give it this amplified state, or give it this open gate state. The ghost. No, this is how I find my veins with the thermal imaging. I'm a ghost. I mean, that waveform output is mad too. It's kind of crazy. You have a healthy arm. I get blood drawn a lot for high iron. So much iron in my blood. I don't get it. Things are just super broken. Or maybe they're fine. I don't know. Like if I give it all the accent actually makes it. Were you a band kid? No. I played piano, but then I sang. I was in choir. So I can still read music, but. What up, Pyro? Yeah, I don't know what the hell's going on with this thing, man. This should have so much more oomph on the outset. There should be stuff happening here. No, I don't have I said I don't have a working one. That's one of the big problems here. That's why I was looking up for like a simulator of the thing. Like whoa, that's a weird view. We got the manual over here. Get a working one and compare. I'm tempted. None of this is the right thing. Oh, yes. Perfect. That's what I need. Hook this up to my fucking brain. Let's see here. I don't think there's a lot of people selling M303s on eBay. $699, free delivery, though. Yeah, so I'm not about to go out and spend $700. Used. Perfect circuit. Are you sure? Are you sure this thing wasn't plugged in wrong? Are you sure it works? No access to an M303. Have a refurb, various synths and samplers. It's okay. It's okay. That's part of the charm of this one, is that this is kind of an impossible project. This is within my means, though. I can fix this. I should be good at this. I've failed on a couple different fronts with this one. It's just kind of eluded me. So I'm kind of just going over it and seeing what goes where, and if maybe there's something I overlooked. But I have replaced this op amp here. Not even sure what it's doing. It has something to do with this guy here, which feeds back into where the waveform is created. I can fix her. It's not like that. I can fix her. I volunteer. It's tribute. But yeah, I was working on Dave's 303 for a while, and somebody else saw that and said, hey, I got a broken 303 too. I'm going to send mine in. Would that be okay with you, Bother? And I'm like, all right, hell yeah. Misery loves company. And it turns out they're both broken in very similar ways, although Dave's seems to be more broken, which is really very sad to me, because I've replaced all of the components that have to do with the waveform generation, and I'm still getting more problems from Dave's than with the users send in one. I don't know what's wrong, but we keep going. We keep going on these things. We don't give up. Our waveforms are coming from here. This is some type of a weird filtering. We're triggering a PNP transistor with a capacitor across it, and we've got resistors that are biasing the leads of the capacitor. So that's kind of what's, in my mind, that is what's creating the pompadour, I feel like, because we've got a weird sort of, when it goes positive, it goes, ugh. I'm on an electronics quest. Yeah, it's a very underrated game, this electronics quest. It'll age you. It'll certainly age you. All of the preposterous things that you'll experience along the way. I believe that's what's going on here, but I haven't done a full analysis, and it would be nice if I could maybe put some of this stuff a little bit, like put it down on paper a little bit better. I probably have it in here. Do I have my outputs somewhere over here? I don't think I've done any of the outputs. Those are filter in, filter in. This is Control voltage in, slide in. I haven't gotten to the output in this one, I don't think. That's envelope out. That's just repeating the envelope in, right? Something to do with that. Accent in. So this is sort of the final stage manipulation, but then I kind of ran out of, I stopped over there. And here's the penis ladder filter, which is just a bunch of transistors put together, and then you'd input your stuff into the one end, and then it would turn into current on the output. You got to turn it back into voltage, I think. And then this is sort of the external control. But this isn't organized. There's not a lot of data here, so this is really our best working document. This has everything on it. Okay, so from here, we have a sawtooth wave coming in from outside, and that is on this test point here. That test point looks like this. Here, let's just get out the gate. Let's go to VCO out. We get that wave on our VCO out, and then if I go to the test point, that would be this right here. Nope, that's the wrong one. That's the one after the transistor. This is the test point. So this is looking a little bit more like what we should see, and we actually get an answer for why it's cut off in the way that it is. Why does it have a flat spot in the wave? It's because it's going from 0 to our limit of 10 volts. That would be the op amp. The TL074 is what is limiting us there. TL074 is not a rail-to-rail op amp. It doesn't go to plus minus 12. It goes VPP and VCC plus minus whatever 2. So it gets close, but it can't quite get all the way up there. That's why we have that flat spot of the square wave. Now, here's the thing. That's not the problem. This is why I think everything is functioning perfectly fine on this thing. It's just for some reason it's not outputting. I don't get it. If I do TB303 repair manual, there is a service manual, and the service manual has some extra notes. It's a big manual. We gotta let it load. These are all image scans. So here's the TB303, the legendary acid house synthesizer. Beautiful. So moving along, this is an early 90s repair manual. They give you all of the stuff. They tell you what everything is. Oh, it's beautiful. It is a beautiful repair manual. Show you what all the chips are. Now this is all of the digital controls. We don't have any of that in our module. Digital controls have been cut out in lieu of having modular synthesizer style controls. So here is the heart of the TB303. And this is where we get our waveforms from. And you can see they've got a couple waveforms pointed out on this. Now this is not where our waveforms are. Thank God for the repair manual makers. Well, here's the problem, is that our device is not the TB303. We are not the TB303. We are the M303. So our voltage levels are different. Our structures are different too. I don't know if the waveform is being made in exactly the same way. You see the match pair transistor right there. And then our voltage controlled switches are these weird things. So this is where we're connecting more circuit onto the circuit. We have something of a map. This is like a loose representation of what the other one is, because they tried to make it sound as much like this as they could using modern, SO-sized electronics. So we do have something very similar to this happening. We've got our pompadoured square wave, although in this case, the negative part of the square wave is also showing that it's got a little bit of kind of a pompadour thing going on there. That's a little weird. And then we have our triangle wave that it's a little bit cut off, except that this one is all the way up at 12 volts. Ours is limited by the TL074. But those go all the way into a waveform switch. From there, I guess they go out or something. But that stands to reason. The square wave is being created, yep, 2 resistors, 100K and 10K, across a across a capacitor. I keep saying diode. Sorry. I do know what electronic components are some days of the week. But yeah, we've got a transistor sitting here with a big capacitor on it, and then we've got our 2 resistors at different values above and below a capacitor. I believe that that's what's creating sort of this the little swoop in the square wave. Problem is, our voltage levels are totally different from what we're seeing here. Could it be all this stuff doing it? Or is this the intended voltage range? Something over there is making a high-pitched squeal. Something over there has a transformer on it. It's going in that manner. Yeah, I really wish I could find an M303 that works. That would be very useful to me. Here's the ladder filter as they describe it. Now, the only problem I have with this working manual is that they've moved all the controls off to the side, and that creates kind of a mess. It creates a lot of these sort of long connections to follow. I would rather this be smushed into a smaller representation of what's here. They also kind of squished their circuit elements so that they could fit this all on one page, which is kind of a disaster. Multiple pages with logical, forms of groupings and stuff like that would be very nice here. A singing inductor, yeah. It's fascinating. We got the shapes and some of the voltages are different, and that's okay. Yeah, that's the thing is like Acid Labs was putting this together, and they said we need to introduce a control voltage into this part. So how do we do that? And maybe I'm just assuming here they decided, oh, well, if we limit the voltage down from 12 volts and we put this on the positive of the spectrum, then we can have this particular type of amplifier structure coming in here in order to have a control voltage influence stuff. Like those are the considerations that they probably made. And also the fact that, hey, TLS74 is like easy to find. So I'm wondering if this is totally fine. Like if this amplitude that we're getting here is completely okay. I mean, it is 4 volts peak to peak, which is not unheard of, although Dave was saying that like audio in a modular synthesizer thing, like we're talking like plus minus 10 volts. Like they really cook audio. But plus minus 5 volts is, we see that a lot in like the mutable instruments circuits. Like if we look at, I don't know, edges, we need to look at the open source on some of the blinds. Like if we're getting a control voltage in, we're referencing it plus and minus 10 volts. Although that's for the shifting for digital. But like plus and minus 5 volts is not unheard of. That's not quite what we're looking at. Maybe like clouds. I use mutable instruments as one of my primary references because they are a very reliable circuit creator. Emily Gillette has been at this crap for a long time, and they know quite a good circuit. So these are refined designs, and I love using them as references because they're spot on. They're as simple as they can get, and they're as functional as they can get. What's happening with these negative 10 voltage references is when you get a plus to minus 5 volt signal, that is the number line. It's centered on the number line, right? And we're trying to input it into a 0 to 3.3 volt device. So what you do is you take that plus minus 5 volts. It is a 10 volt spread. You move it down. You move it down so that it's from 0 to minus 10 volts. You do that by introducing a reference of negative 10. That way, if you are at positive 5, well, actually, wait, how does that work? Whatever. The point is, we're offsetting it, right, by adding this analog reference, and it's actually balanced 200K versus 100K. So it moves you down on the number line. Once we're down on the number line, our voltage references are in the negatives. We put it into an inverting amplifier, and we're damplifying it. We're taking a third of the voltage away, 100K to 33K. Taking a third of the voltage away, what that does is that turns that plus minus 5 volts in a 0 to 3.3 volt range, and the MCP 6004 runs off of 3.3 volts. So it cannot go above that voltage, and so you don't blow up your microcontroller. It's a very clever way to do it, and it's how I do it. It just kind of normalizes all your stuff and gets it into the right part of the number line. So there, I mean, our control voltages coming into there, or audio signals or whatever, are plus minus 5 volts, which justifies the voltages that we're seeing coming out of the VCO out to the M303. That is in the range of plus minus 5 volts. I would say that that's appropriately in the range of plus minus 5 volts. But of course, then Dave goes, no, it's too quiet. So I don't know. I think that might be normal function that we're seeing right there. And in kind, we have, well, let's check to see, number, channel 1 is, yeah, they're on the same range. So, I mean, that output, although it is completely mangled, is the appropriate amplitude if we're talking plus minus 5 volt devices. Though some of these modules are totally cooked, right? You can see audio signals of like 10 volts, plus minus, there's a 20 volt spread for plus minus 10 volts. So I don't know what to think here. Is this one fully repaired? It doesn't really seem like it though, because that waveform is completely mangled. Like, I'm not getting a triangle out of this thing, am I? Turning off the VCF mod, I've lost all my amplitude. Resonance would probably bring some of it back. The cutoff just kind of gets rid of it, doesn't it? Yeah, it does weird stuff to it. And then I don't have any accent on there, and decay is all the way up. Envelope mod doesn't really, well, kind of. And then if I flip it over to VCA mode, that shouldn't look like that. Because technically I am gating this thing on at the same frequency. Maybe that's what's messing with it, is there's something kind of messing with the, but I've got the decay all the way up. So all this thing is doing is charging up that gate signal and making sure that it stays open. VCA, I'm amplifying it all the way. Damn it, I don't know. What do you guys think? You know, some weird stuff is happening in this circuit. Maybe I just need to get this into a state where I can actually, you know, test it fully and get these things working properly. Because right now it's not really cutting it. I've got 6 waveforms that I can output. Some of them are broken. If I finish doing the circuit on that thing, then I'll have a comprehensive tester, and I don't have to use crimes and ornamentation to make like a gate and a control voltage. I can use that thing that'll create a waveform and a control voltage, measure stuff back, and maybe I can get them into a state that way. It's just I don't have a functional comparison to a working M303. The part of the circuit that comes before all of this stuff that we were looking at over yonder. So the test point we were looking at is this one right here. This is where our 0 to 10 volt signals coming out of the TL074, which is being fed 12 volts over here. So this is doing what it should be doing, and it's getting a triangle wave. So it's getting the triangle wave from where? Over here and back up to here, and here's that transistor. So we have a 330, I don't know if that's a 1 or what, whatever. We have a 330, and that goes over here to this transistor. Why is it being fed from over here? Oh, because tune is going into there. So this is tuning it. Well, I guess that makes, you know, I replaced it and then it works exactly the same. Over to here, over to this set of transistors. What's this? This is where it's coming from. Wow, that's weird. This, oh, it's not, no, it's on the other side of the resistor. You could have moved the resistor and had fewer traces. You could put it right here. This is unoptimized. And then that's coming from this thing switching down to what? Holy shit. It goes all the way around over to here. This is where things get a little hinky. Yeah, it would be nice, but we just can't rely on that, unfortunately. What is this layer? I've got this like highlighted layer. Is this something that I did and I can't undo? Oh no, this is me trying to understand the oscillator circuit. I see. So there's another test point, and that's right here. And it's coming off of this transistor. I don't know what that transistor is doing precisely. It's hooked up to the rest of this stuff. Man, it gets weird in this area. This is like the primary oscillating section of this. Let's find that test point. and just drop in on it. That's the microscope. Let's drop in on this test point and see what happens. So I guess we can get rid of our output because we know it's all hinky. And we were over here, and then we moved closer to the adjustment guys. I think it's this one. Huh? Okay, nothing? So it's either happening in such a small scale, or I don't know, something else. Interesting. Yeah, see, this is our output from the TL074. A healthy output, very healthy output. Yeah, it would be nice to just get like an O-scope reading from the various... Whoa, what was that? Oh, that was me just hooking up to it funny. All right, I'm at my wit's end. We tried one thing. It didn't work. I have a lot of work to do on this thing in order to figure out what exactly is going to get these things into working shape. This might be in working shape, but it's doing weird stuff with the output. We probably should be seeing something a little bit more akin to that triangle wave, and it's not quite that triangle wave. Does that mean this bad capacitor? I don't know. That would be in the section that we've been looking at today, which is not this oscillating section, because we've got a very healthy waveform coming in on this test point right here. And then we have sort of a choppy triangle right here. So very healthy waveform here. Choppy triangle going into this stuff. I don't know. I do not know. This is beyond the purview of knowledge that I have. So it's possible that something in here has gone bad. Maybe one of these capacitors. Maybe this one. But it could also be totally fine. Man, I wish I had better answers for you guys. This stuff gets very frustrating sometimes when you're at a low level like this trying to figure out what's going on with a purely analog system. It's hard to kind of narrow down the possibilities of what could have gone wrong because one thing affects everything. It's well, I'm hoping it's not a PEBCAC. That's what I'm getting at. If this thing actually works perfectly and it's my fault, I'm measuring it wrong and thinking that something's wrong. That could be. It's just like everything I try is just not doing anything to change the outputs on this board. We're right back where we were, and I guess that makes sense because I replaced this one. But it doesn't look like anything is totally outwardly broken. It's possible that this transistor or this transistor could have something wrong with it. But it could also be possible that somewhere in the rest of this vast circuit, something else is wrong. Like the reason that it's becoming a weird like dimple could be, I don't know, the transconductance amplifier, the end stage amplifiers coming out of it. Spurious stuff running around these transistors here. I do not know. I'm very frustrated. Anyway, I guess I'm gonna end there because I don't really have anything else to do here. I can't poke in on the top of the circuit anymore. I don't have the headers on the back. I thought we were gonna fix it. I bought all the parts that I thought I needed to replace. It's possible that I need to get like this thing, the 4106, but I guess I'll organize my parts and figure out what I have, and we'll put the M303s back on the shelf once I get circuit boards in. That's going to be soon. Until then, we can do a little bit of board design. I could do another sponsored stream, and we'll get together the module tester, because it would be nice if I was able to plug the M303 in and definitively know that I am sending it a gate signal and that I'm sending it appropriate like CVs for audio and stuff like that, and then be able to measure those back and give it a frequency. I can do that with the scope for now, but I would actually like to make the hardware for this so that I can set up like a test and program the microcontroller to do the test. That would be nice, you know? This whole comprehensive like little device that I'm building that's supposed to be my modular synthesizer testing setup. It's going to be very nice when it's done, but right now we're running into more problems. Also, I need to find what happened to that one screw. There's one screw that looks like this somewhere in the shop. Yeah, Tuesday is going to be the next stream. Let me hit the end card. I'm not gonna drag you guys around on this stuff. I guess Flatulent Gonad probably isn't streaming because he's here. Actually, there's no guarantee of that. Hold on, I gotta check. If you're streaming, so help me God, I'm gonna fucking ban you. No, he's not streaming. Keep an eye out for all of your favorite streamers, which aren't me. I'm gonna let you guys figure out. Lost screw, hope it's doing okay. Yeah, I don't know. I'm thinking maybe I want to find like a similar screw and order one, because I tried to keep track of these things. Might in a bit. Eating cheese and toast and messing with Node. So my Node Red things, I'm having a lot of trouble with. We did this at the beginning of stream, and I think GoNout is still there for it, but I can't test this until I stop stream. So what I've set up is a stream for me to hit stop streaming, and then I can actually look at some of the things that have rolled in over yonder. Nope, over yonder. So I'm going to take a look at this debug output and see what happens, and hopefully my light will work, because then I can move on from this infernal stream light, and I can actually have, what do you call it, a Twitch API node in here, and we can start working on them. I am back with great ideas. I'm just stopping the stream. I don't like to drag it out. If I got something to work on, I'll work on it with you guys. I don't have anything else to do, and hitting stop stream is going to fulfill my little research thing right here. Node-RED is feeding the thermal printer again with Wi-Fi instead of RS-232. That's pretty cool. I'll get the good one out right now. Oh no, what is this going to be? What's the good idea? I'm going to wait for it, and I'll put up the end card again. Yeah, we're posted on the Discord, so we don't have to all wait here. Here's the end card. Make a dedicated pedal for Wonderwall.